Sabrina,
Shawn,
welcome to the show.
thank you for having me.
Man, I've been excited about this. So you're labeled, and I know you're probably going to downplay this, the next Einstein. You don't like that?
No, I mean, it's just not accurate, but I do like this notion of, I don't know, thinking a bit about what that legacy is and like our field as a whole and how do we kind of leverage that or do good with it.
Well, I think we're going to get into all that. But, this stuff you're doing, I don't even know how to say it, but it sounds like, and we're going to get into it in a minute, but It sounds like what you're studying is if everything is a hologram.
Yeah, most literally, yeah. Like the thing that I study is that, and I do find it's fun, like to kind of take a step back and talk to people who are not researchers to see how they interpret the words that we attach to things, or how like visceral, literal, like the researcher versus like the person you're talking to takes it.
Right on, right on. You ready to get into it?
Absolutely.
All right, let's do it. I'm going to start you off with an introduction here. Sabrina Gonzalez Pasterski, born in Chicago, Illinois, first-generation Cuban-American. At age 9, your first flight lesson ignited a lifelong obsession with flight and physics behind it. Between ages 12 and 14, you spent 2 years building a single-engine Zenith. Rejected by Harvard, waitlisted at MIT, you got off the waitlist because of the airplane you built. Earned your PhD from Harvard in 2019 in high-energy theoretical physics, leading the Celestial Holography Initiative, a project aimed at encoding the entire universe as a hologram to unite quantum mechanics and general relativity. Named to Scientific American's 30 Under 30 in 2012 and Forbes 30 Under 30 Science List in 2015, one of the Albert Einstein Foundation's 100 Greatest Innovators in 2018. First woman to chair the flagship annual strings conference for the global string theory community. First female to graduate #1 in MIT physics. And like I said before, many consider you to be the next Einstein, which you hate. You don't like that.
I mean, I think I'll probably benefit from it too much, but that's a bad thing. Yeah.
It's a cool label.
Yeah.
Be proud of that. But so actually, before we get into it, just can you give me a quick? I think I know what string theory is, at least a little bit. But is this like what do they call quantum communication? Where they
so basically, so like quantum information, or the kind of like the sense in which you might be thinking of, like if you were talking to someone who does quantum computing and like those facets, is more like in holography. There are definitely connections between foundational aspects of like entanglement and different like protocols you can do in a quantum mechanical system, and then mapping it to a gravitational one. So string theory is not related to that directly, but there's a sense in which the research I do probably is like more closely related, if that's what you're asking. But basically, the whole point is we want to try to, as a field, not individually, understand like what the basic rules are. What are the laws of nature? And if you aren't going out and measuring things, what do you really have at your disposal? You're roughly trying to use mathematical consistency of your frameworks to try to piece together a picture. And so if you have rules for the very short distance physics and very long distance physics that are kind of in their own world, and you want to try to have a framework that connects both of them, you run into various problems. And string theory is one example of a route that people have found to kind of avoid the pitfalls of like understanding how to have a graviton or how to have like a quantum mechanical system with gravity. But in practice, you're roughly studying one little facet of these mathematical frameworks and trying to push it pretty far or generalize it to different situations.
Okay. I read something that China is working on communications where they will vibrate half of an atom, and then no matter what the distance is, the other half of the atom will mimic exactly what.
Talking about some entanglement or what?
Yes,
I don't know.
That's what I was thinking about, quantum entanglement.
Sure. So I think that I am less like on top of all of the experiments when it comes to trying to see like not just entanglement, but maybe like some sort of like position dependence or whatnot, which is like closer to like seeing like how gravity and quantum interface. But so I don't know exactly which experiment, but I know that there's a lot on like kind of there's a lot of progress on like the quantum computing side of things, which I guess is like the closest thing to an engineering subfield right now within like high energy theory, but a little bit not high energy adjacent.
All right.
Yeah.
Right on. All right. So Couple things to crank out here.
Yes.
We got a Patreon.
Okay. You
It's a
got
community.
your Patreon. Yes.
Yep.
So we got to make them happy.
They're the reason that I get to sit here with you today.
Super cool. Yeah.
So they get the opportunity to ask every single guest a question. This is from JD Pardon.
Okay.
At 12, you weren't playing video games. You were in a garage building a Zenith CH601XL. What did that mechanical grease under the fingernails experience teach you about solving abstract physics problems that a textbook never could?
I think it maybe didn't teach me like enough for what I have done so far, but it definitely instilled a sense in which like there's a value to trying to find the things that can be straightforward and systematic and build something cool out of it. And I think that that's one thing that maybe theoretical physics personally felt like it was lacking because I had this bias of growing up around people who like built cool shit or whatnot is like, is there a sense in which you can try to find the engineering aspects of what you do and the systematic things and like build tools for that? So that's the thing that project probably has instilled in me, but I don't think I've like lived that out yet.
Right on.
Yeah.
Right on. And then I got you a gift.
Okay.
Everybody gets a gift.
Gummy bears. I heard. Thank you. Cool.
Vigilance League gummy bears made in the USA up in Michigan. Oh, you want to try them? Go ahead. You're going to love them.
I hope I know how to open a damn bag. Wait, sorry. Yummy. Those are good.
Nice.
So what made you want to have gummy bears as a product? Because it's super fun.
Actually, I was going to do CBD gummies for sleep. And my
You do
marketer,
melatonin ones or something.
yeah, my marketer said I'll get sued for catering to kids. So I said, fine,
Yeah.
fine, we'll just do regular gummy bears because I like those too.
I can eat them in
Right?
Yeah.
Right?
bulk.
But so I want to do a full life story on you and then get into everything that you're doing right now. So where did you grow up?
I grew up in Chicago, Illinois, and like in the city, but like near the outskirts of the city, part of the city where a lot of like firemen and cops would, I guess, live because they had to live technically in the city. You know, I love like Chicago is a kind of fun, like well-designed city where you have like a lot of like awesome public schools. And I went to a Edison Regional Gifted Center was nearby where I lived at the time. My parents picked that location to be near nice schools. And it was, you know, fun growing up, awesome having like smart peers and being challenged in school. And then, yeah, I guess I can keep iterating on different parts of it, but I definitely had some enthusiastic parents. And that's where this whole like taking advice from mentors and kind of just following different rabbit holes led to where I am now.
What did your parents do? Or what
So
do
my
they
parents
do?
are both lawyers, but they're not lawyers in like the in the way they're lawyers fancy sense. So my dad for most of his career was a public defender. So he worked for like Cook County. And then my mom works for the EPA. So more like I think the regs for like making sure that companies that accidentally polluted like various like groundwater or things that like affect people, like they have to pay and fix their problems. So
Wow.
Yeah.
So nothing to do with physics.
nothing to do with physics, but my dad did have an electrical engineering like undergrad degree. And so definitely growing up, like we were the ones doing repairs in our house. We didn't really hire contractors except for maybe some things that had to be welded. So that was interesting too.
And you did your first flight lesson.
Yeah.
Was your either one of your parents a pilot?
They weren't at the time. My dad got a license he got a license at some point pretty soon after, but maybe he had a relative back in the day that had flown or whatnot. And like Harry Potter was cool at the time. And I think I wanted like a flying broomstick. So like they definitely convinced me like Santa Claus was real. It was really funny. I think they'd used like these extrinsic motivation things to like get me to be a good kid or whatnot. So like I was convinced Santa Claus was real because the presents were awesome. But like I guess I got a little greedy and I wanted like a flying broomstick because like Harry Potter was cool. And then they're like, flight lessons. So like, I
Wow,
mean,
that's cool.
But it's like, and it's funny because it's a bougie style hobby, but it's very much more like they would just do anything for their one kid, if that makes sense. Like, it's like, yeah.
That's
'Cause
awesome.
my mom's family, like, so her dad was like a carpenter and then they moved from Cuba. And then on my dad's side, his father was a bit in trouble with things. At some point, that's why he became a public defender. And so to them, they'd made it. And then they want to invest in their kid.
Man, and you build a plane,
Yeah, I mean, but
plane,
the thing is,
age 12.
yeah, and that comes from the fact that like I mean, like people do this, right? So what's the way that this stuff works out? So you're a 9-year-old flying, and then your dad's like, oh look, my kid's like so cool flying. Like who are these people that they can meet? Da, 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 da. You go to a lot of like air shows, like because he was a lawyer, so he has some sense of regs. Like there was this kind of fun thing of looking for like how can you get around the fact that you'd have to be like 16 to fly alone in the U.S. But in Canada, you can do this at 14. And so I had found out that like Jamal Larkins was this aerobatic pilot who had gone up to Canada to flight train to get through this kind of legal loophole of how old he could be to fly alone. Wrote an essay about it. And then I started getting these like mentors in the FAA. And then my dad was super encouraging of like going out and networking. And it's very easy to network when you're a cute little kid. You don't have to be good at public speaking. Like you're just like, here's a kid with some pictures of you like flying or like with a big parachute behind you and an airplane like it's like overpowering. And like you can walk your way into things. Like you bring like Krispy Kreme donuts to the FAA. It's perishable, and you start making friends. And then you see all these people who are, building kit planes, and then you're like, damn, it's hard to get into school these days. Like, can you do some sort of trick to get into either like these like selective high school, IMSA where I went, or MIT? And yeah, and then I always just trusted my like I thought my dad knew everything because he was really like kind of a jack of all trades, fixing things around the house. So when he is like over my shoulder or like teaching me how to do some things, and I'm just going and riveting things together, I'm like, this is great. I know if he says it's fine, it's fine. And it was cool because basically before it turned into this set of mentors suggesting, oh, you could do this thing, like whatever. It was just that much effort put into like school projects. So I had I think whenever like people were like first burning DVDs, we'd have like a room in our house. So one of the bedrooms, they painted chroma key blue that I would go and like reenact little scenes for my history projects and like be filmed and put into like some like Doctor Who episode or something like that. So it was we basically were just trying to do like say A+ star on every little school project, which is a bit of a waste of time, but just a funny little like effort. And then to translate that into something where then the narrative was like, okay, you're gonna take flight lessons. You're then gonna like try to build an airplane and then want to work for these aerospace companies, like a linear kind of story arc with a bunch of like fast-paced like projects type of thing in between was something I think that came out of this otherwise like intense like go do it well attitude.
Well, yeah. What age did you start reading?
Oh, I mean I don't know. I don't recall myself as being like a better reader than my classmates. If anything, when I was in kindergarten, like Alice and Larrabee could read all of the joke cups, and so like I mean I could read, but like maybe my vocabulary was not as expansive. And so then my parents would like buy all of the Dixie joke cups like in bulk to then be able to at least read the words on but then the kids still would just go to Allison, maybe because she was like the first person like that they knew could read the joke cups, or because she had more friends, I don't know. But like yeah, so I don't think I was necessarily reading faster, but I probably was talking a lot early on. And they used to do a thing where it's like if I could write it out, then they'd let me, like if I asked for a car ride at some random time of night, if I could write it on the little chalkboard, they'd take me on a car ride. So a lot of extrinsic motivational.
Right on.
Right.
Yeah. Do you have any brothers and sisters?
I don't, and that's probably why all the intense story stuff is because it's like one kid, one shot.
What else? I mean, what else were you designing, inventing, building as a kid?
Mean, I would say that like it wasn't anything that like before it would have been just like going all out on every little class project just for the heck of it. Not nothing that cool. And I think that, but the one thing is it was like kind of like it was pretty clear to see how easily like the goals were shaped by either like strong reactions to or like taking on ideas from like the people that you talk to. So like when I was flying, everyone would be like, oh, one day you're going to be like flying our Boeing one day when we're like taking a vacation. And I'm like, no, I don't want to do that. I don't want to do that. And then you see these people building kit planes, super cool at these air shows. When you're putting it together, they're like, oh, one day you're going to be building the Boeing. And I'm like, I don't want to do that. And so it was just more of like someone says you can do it. And then my dad's like, yeah, you can do it. And then we see how you can do it. Or then someone's saying you will be doing it. And you're like, no, I don't want to do it. And so then you pivot. And so that's how I accidentally pivoted into physics later, like we can get to, because I was like, it's not as cool if you're not actually like, there's the designs aren't really changing and you're not like putting together. I mean, it was somehow more fun to have something where you do straightforward work. Somebody else kind of told you the steps for you modifying it or fine like that. But then you have a product that you built versus when you're just engineering something it's like a little too theoretical. I might have go the whole other extreme of purely theory, which is maybe a bad choice, but but it kind of
What did get you into physics?
yeah. So funny story. So basically, I think the first hint at it was the high school I went to, this math and science school. Like all of the like a large fraction of the faculty had PhDs, and so I didn't grow up with people who had PhDs. I mean, my parents both had like they're lawyers, so they went to like state schools for that. But suddenly now all of your peers think they have to get a PhD to be cool. So that's a weird thing. Like you suddenly have this mind shift where, okay, I need a PhD. Probably not true, but like that starts, I mean, definitely not true, but that starts seeping in. The person who founded my high school was like a former director of Fermilab, and he'd have like these lunches with Nobel laureates with like, they'd come in and give talks, and then he would have lunch with the students if it was just him every Monday or something, I remember.
Wait, hold on.
Yeah.
I thought you went to public school.
I went to it's a public school. So
This
like
is a public school?
so this is not Chicago public school. So I went K through 8 Chicago public schools, and they have like these kind of magnet like programs, like gifted center type of thing. They have different types of magnet programs. So CPS is like so large that they have fun schools for kids who like school, I guess.
Okay.
Then I went to the state school that's 3 years boarding school paid for like mainly by like state of Illinois. Math and science school, Illinois Math and Science Academy. So I think it's funded under the umbrella of like University of Illinois or whatnot. There's precedents in South Carolina, I believe, and Texas and others where it's just like a STEM boarding school that the state runs. That it's public.
Wow.
But it's like you get this. You have to take the SAT to get in and things like that. But it's kind of actually cool that there are these. Like
That is cool.
Yeah, public schools.
You took the SAT to get in?
Yeah, I mean, and the scores for kids getting in like to high school are not that good. And I definitely wasn't the type of person who did well on standardized tests. I did well on like the ones in school because I cared about the teacher I'm trying to impress. But yeah, it was neat because it was a public school, but it was very much like a little bit of this vibe of like a
Gifted.
private, type of school experience in the sense of, you're at a boarding school. But it was nice because then it could get kids from all over. Like even our elementary school was like you're busing kids in from all over the city. And so you have a lot of like just gifted kids from like various socioeconomic backgrounds there. And then similarly with like the boarding school aspect lets you be from anywhere in Illinois.
Wow.
So it was nice.
Wow.
Yeah.
If you're like me, health and wellness is extremely important to you. But how do you know who to trust when it comes to the supplement industry? We have all these companies. They pop up every other day. They're all selling snake oil. How do you know who to trust? Well, here's the most important question. Who wants to take the biggest, most massive shit of your entire life? Bubs is a company I've used and trusted for a long time. They make great products, have rigorous quality standards, and they are a long-time supporter of this show. And they have the recipe for the biggest shit of your entire life. I love their collagen peptides. This isn't just any collagen. It is a benchmark of trust and performance. It's crafted with integrity and backed by NSF for sports certification, giving you their assurance of its purity and potency. Bubs Collagen Peptides help support your joints, help enhance recovery, and help revitalize your hair and skin. And yes, it will help you stay regular. Bubs was founded in honor of Navy SEAL Glenn Bub Doherty, and every product supports veterans with 10% of all profits going to help military men and women transition back into civilian life. And now for the recipe for the biggest and best shit of your entire life. Bubs Collagen Peptides mixed with Bubs apple cider vinegar gummies, and you have a recipe for success every day. Bubs Collagen Peptides. Bubs Apple Cider Vinegar Gummies. Ready to upgrade your life? Visit bubsnaturals.com today and use promo code Shawn for 20% off your order. bubsnaturals.com/Shawn. So that got
MIT
you.
expensive costs a lot.
So all the PhDs got you into physics.
So it was the PhDs plus the fact that the founder was a physicist, like a Nobel laureate in physics, who then somehow, when like the plane is final assembly, like near at Aurora Airport nearby this high school, and he thinks it's cool. He's like, "Oh, you can be a physicist," and then suddenly that gets into our minds. And then all of these aerospace like executives who were running these like private aerospace companies. So I guess not Richard Branson, but Elon Musk and Bezos both liked physics for whatever reason. Like they either like dropped out of like some physics-ish like material science degree at Stanford or thought about majoring at Princeton. So my heroes were these guys who like could just do cool shit. Like they had built a company to have the resources to then do something that's valuable but not necessarily profitable. Or I'm sure they found ways to make it profitable. But I thought that was
I think
cool.
they're doing all right.
I think they're doing all right. No, but even in the scope of like, can you like, how do you just build a?
No, I get what you're saying.
So I thought that was the coolest thing, and I wanted to be like that. And I figured, okay, like if I just work for them, would I ever still be like that? I don't know, maybe. And I got a little disillusioned about like what's the product I'm going to build. If you build like some suborbital thing, if like you accidentally kill a rich person, is it going to just be dead? You know. But they did a good job. Like they didn't do this. I'm surprised. I'm like, damn. Like
if
safety.
you accidentally kill a rich person, what do you mean?
No, so like you're so that type of thing scared me a little bit. And then I figured they like physicists. So like, how can I be cool to the people I find cool? Let me go into physics, which is like the wrong reason to go into physics. And then by the way, like I grew up with a bunch of the kind of like mechanics / engineers who maybe see like the physics as like this bottleneck that the physicists aren't doing it right. Like there's got to be some cool tech that can come out of this. And I'm like, yeah, I'm going to go in that field. And it's like completely not like, you got to hide that at least when you're actually trying to like get by in the field.
Right on.
So very much a wrong reason to go into the field. But, yeah.
Wow. What was the first project that really grabbed your attention? Because you obviously love it. You're still in it.
I'm still in it. No, but I still think the thing, it's for that bigger picture goal. So I think the thing that grabbed my attention is more, you know, I liked my math and science courses in school. I think that maybe in hindsight, looking back, just the notion of computing something draws your attention in a way where then once you're in it, you're hooked. And that's good for my job mechanically. In the sense that like our job is to compute things. But I do think that I was still more excited by the bigger picture view or this notion of the possibilities of what physics could do than in practice what it is, in the same sense that like, you know, someone working at Google like isn't necessarily actually like gets to think about search. They're doing one specific little widget or something, you know, type of thing. But yeah.
Right on.
Yeah.
Where do we go from high school?
Oh, so from high school, we go to being a little bit too cocky and like being like MIT for aerospace, Harvard for physics, and then not getting in because you wrote too many poems or didn't really like. I think that the one thing about the admissions to these schools, I mean, it's so much luck. So that's a bit sad. I think that grad admissions is fairer because you're already kind of differentiated in your skill set, and like the people admitting you are the people who care about the field that you're going into. But I thought like all these other kids are taking the AP courses. They're checking off all these boxes for their extracurriculars. They don't want that. They want something different. It's like, no, maybe it's just like, you know, like they're seeing a large array of applications. You don't want to like be anomalous in a negative way. You just like check the boxes and more or something. I think I didn't handle it right. But then I knew how to bother people because I'd been networking since I was a kid. So we found like Sheila Woodnell or who else? I think like she might not have helped with admissions. It was more like Earl Merman. But basically I'd be this kid with this little like photos of this airplane build, walking around, and like my parents would drop me off at different places. So like wandering MIT hallways to try to like say hi to someone with this book. And I'm just like, okay. And then I just patiently wait. I mean, probably not as cool as like waiting for a little sniping mission, but like you're just there. You're like, somebody's here. I'm going to say hi to them. The mission is to get this book in the hands of some MIT professor.
Wow.
And you meet cool people, and it was like you give flowers to the secretaries or whatever, things like that. So a lot of networking as a kid, and eventually it helped because I had some friends who could be like, hey, admissions office, like maybe she didn't present this clearly enough in her application. This is kind of cool. Let her in, and I got in off the wait list to MIT.
You got in where?
Off the wait list to MIT, yeah. That way, yeah.
Because you tried to get into Harvard too, right?
Yeah, and I got rejected. But I mean, to be fair, lots of kids get rejected. Lots of awesome kids get rejected. It's something more about like teaching you not to like rely on other things happening for you that you can't control, right? So like, yeah.
What was it that got you off the wait list at MIT?
It was probably this type of networking thing, like, you know, trying to like rely on some people who could vouch for me once you're on this wait list.
It wasn't the plane?
Well, no, there's a plane. Exactly. So I'm saying this whole
how did
me
the
going
plane-
around with like the little like photo book of the airplane and then meeting
You
MIT.
literally brought the photo book of the
Believe
airplane.
me, I would like Like I had little business cards back in the day. I mean, I like it's very cringy.
That's
I blame my
awesome.
dad. I blame my dad. No, but like it was like you had little like photo books of the plane, little business cards, and like thinking of who you want to meet, and you're gonna meet that person, and then you're this cute little kid. I mean, like you get a little bit less cute once you're in your teenagers, but between like 12 and 14, you're pretty cute. So like walking around like with that, like trying to introduce myself to like various MIT faculty, say, or like at the air shows, various people in the FAA, or like maybe Peter Demandis, or folks who had done cool stuff in either like the private aerospace, like Anush Ansari had gone up in a Soyuz capsule, and then Demandis had the X Prize. So like definitely a lot of like trying to network, but with like little.
Man, that is
Yeah.
I'm going to do that with my kids now.
No, with the kids. I mean, it works. It's like an arbitrage opportunity. It's like there are things that like the kid can get the access and the, yeah.
That's smart.
That weird.
I love it. I love it. So how did you like, how was it getting into MIT?
So I mean, it was a relief because I didn't get into college otherwise, right? I mean, I was very dumb. I was like very narrow-minded in the sense of like, or like laser focused on, I want this thing or this thing, nothing else. I have standards, but you can't like have standards if you're not like what they want. But I guess it helped to be able to have a little bit of that story and some of that network to like petition or whatever, or put a good word in once it was on the wait list. So, yeah.
How'd you like it?
Oh, I loved MIT.
Was it challenging?
Yeah, but I love that. And I think that's the thing is like, actually, I loved it way more than my experience at Harvard, but like, not to say that other people don't, like each for their own, but it was just, I like the fact that it was intense and like you knew where you stood. It wasn't a bunch of kids bullshitting, and you'd take the courses that you're ready for and then get you up to the next speed, and not a bunch of, if everybody gets an A, then you can pretend that you know stuff, and you have kids sitting in on courses they shouldn't be in, and then like, who knows what, it's like babble, versus it just felt more like went in, worked hard, you got something out of it. I love structure and yeah, something helping push you. Yeah.
Right on. Yeah. Yeah. What exactly were you studying then?
So I ended up majoring in physics. So when I went in, there's like a lot of just general institute requirements at the beginning, first year or so. I was able to sneak into being like this internship at Kennedy Space Center with a bunch of older aeroastro kids. And then I think it was after that first summer, I also interned at Boeing. And I guess at the time I was scared of like this whole like narrative of like the airplane build and like flying as a kid, like how much that would confine me. And so I guess my rebelling was like the other option was physics somehow. And so I liked my physics courses. I did well, and I just pivoted into like, let me major in physics because
You did an internship at Boeing?
yeah, but it wasn't, I mean, it probably is. Lots of kids do internships. It was probably because of the kit plane and stuff like that and these connections that I was maybe considered as a freshman or like younger than maybe other people would have. But you end up
You did an internship as a freshman at Boeing?
I hope I'm right, but between freshman and the sophomore year. If I'm not remembering.
I mean, as a freshman, you were named the first in MIT history.
There's a little entrepreneur thing.
Yeah.
But I wasn't very entrepreneurial. I don't have any companies. Lots of MIT kids have companies, but I hope the spirit is there for the wrong application. But when I was at Boeing, I probably, and this is the type of mistake that I would make often, is you make awesome mentors that you want to learn something from, but sometimes you want to not just literally take their advice. And so I think that my family and we accidentally would work for the person that gave you that introduction rather than thinking about, okay, where else at Boeing would I rather be necessarily? So I ended up in this arm where they were doing some cool like R&D for a project that didn't feel like it was ever going to be built by Boeing because it was kind of a McDonnell Douglas acquired branch of the company. And that disillusioned me a little bit, not because it should have, but because it's just like engineering isn't always the same thing, or academic engineering isn't always the same thing as like building something. And I think that I thought it would be closer to like move fast, break things, do cool things. And I think if I had seen any military side of Boeing, it would be a very different experience. But I was kind of just like, sometimes the technology of within a given field isn't the thing that then advances that field.
Gotcha.
And so, and again, because of these stupid reasons of like a bunch of like not knowing enough about physics to realize that isn't the right route. Like, maybe studying like the fundamental laws of nature would help you more than studying like coding or something if like the new tech is like either drones or better engine design or whatever for like pushing aerospace forward. So very naive, but kind of disappointed with the fact that you could see that even at a big company that's doing some awesome things, like there's a sense in which you can get lost in the R&D phase.
Mm-hmm. You just mentioned something.
Yeah.
I think you said that the latest technology in a field isn't necessarily what's going to advance humanity.
Yeah.
How do you make that determination?
So I think what I'm saying is just like a lot of times you can see it in like, and I see this in physics with people who complain about physics who are not necessarily in the in crowd or whatever. And like they can say true things and maybe draw the wrong conclusions about intent or about like what to do about it. I think that oftentimes like you can just kind of see that there's like a lot of low hanging fruit and then it stagnates a bit. And like, I mean, to the extent that like, you know, the design for like a passenger airplane really hasn't changed so much. And so like, do you just look at like, try to find a definition of progress and see that it's slowing down and not blame yourself for not being smart enough, but try to see like, what do I actually care about? Do I like it because I like doing the thing, or do I want a product? And once you have the product in mind, probably it's easier to decide like what you need to learn and go do.
Okay.
Yeah.
Let's rewind for a minute. You had a high school internship at Blue Origin.
A little bit, but that was so short. That was like, I mean, so the internships at Boeing was a real normal internship. And then the one where I was at Blue Origin was some mentors were nice and like let me, I forget exactly. I probably kind of, I'm glad I can pretend that this NDA thing. I don't remember exactly all the utility of the thing that I was playing with at the time there. And then the one at NASA was also very much more like show and tell. It felt like we were learning like operations instead of any particular cool tech, but we got to see a lot of fun stuff on the tours. Yeah.
What kind of fun stuff?
Like I thought the coolest thing was somehow these like tiles where you could heat it up and it would still be really hot on the inside and you could touch it on the outside. Like that was fun. But it was just like going around to different parts of like Kennedy Space Center, literally getting a tour with a bunch of aerospace engineer students. And at the time, and this is kind of funny too, because I used to think it felt a little bit bullshitty to have these, and again, I don't know, like I'm not knowing to insult the experts, but something felt off about there being a whole enterprise around like how you organize your enterprise. It feels like kind of like prompt engineering now. It's surprising how much of a discipline do you make the things that feel like soft skills? And so that internship was very much like trying to see how different parts of NASA were working together or like that. But it's such a high level view that I think I was like, this isn't the tech. And maybe in hindsight, though, I should have like appreciated it more. But I think at the time it was just weird going from like, you know, rivet plane to.
What are the other interns? Were there other interns?
Yeah, I mean, one of them I think ended up going. They were awesome. I was probably just a little bit annoying because I was younger and I was like, ITAR, no, like there's a kid of Lars that's freaked out over like ITAR things. Like it's like who could see documents. But basically they. Like one of them, I think, was going to go in the Air Force. Maybe he did. I hope so. I don't know. I didn't really follow up because I ended up going to a different major later. But I think one of them had interned at SpaceX or things like that. So it was I think I didn't appreciate how valuable your peers are until I started going more towards physics, just because then I got into the whole like research community and stuff. But yeah, I probably was just an annoying little freshman in that thing.
How do you think they felt about you? How much younger were you?
I think we all agreed.
Everybody?
No. I mean. No, I think I wasn't that much younger, but enough when you skip a year or so. Like, right, college is, if you're, how old I would have been, like 17 or something, and they're like 21 or 2, it's still a bit different if you're, they're more independent and like, like kind of.
And then you had an internship at CERN?
Yeah, so then I went over to physics because I guess, so I made that choice for physics because I liked my physics courses, and again, all of these tech people who were in aerospace were my heroes and they liked physics. So I'm like, I'm going to try to impress them. How hard can it be? And then, but the mistake I made was, I guess, that I just kind of took the first internship type opportunity from the person who was technically my undergrad advisor. And so it was at CERN. So CERN is cool, but I'm sure that like I didn't necessarily make the right choice in the sense that I wasn't like scanning all opportunities of things within the field I could be interning at or whatnot. I was very lucky that the one year that the first year I go to CERN, they discover the Higgs boson. But like, science is slow, especially in like a big collider.
The first year you went to CERN.
They're discovering the Higgs boson. That's nothing to do with me, but just the right timing of like.
Discovered what?
The Higgs boson? Oh, sorry.
What is that?
It's like, so trying to understand the the origin of like masses for like these standard model particles. It's an extra field that was conjectured to be there to describe also like electroweak symmetry breaking, et cetera. It's like the field content of like the things that mediate interactions between particles. And so basically they have a new discovery in a way where that's like really rare, but like, you know, sample bias of like, you're in there, they do cool stuff. So like, okay, that was neat. But again, CERN is huge, right? So it's interesting to also see how hard it is to make some measurement for like some quantities within theories that are also esoteric. And so it's a fun thing to see the engineering side of physics research. But again, I'm just a kid kind of like having some fun doing like a little bit of I think it was some just for my undergrad thesis along the lines of like some data analysis back of the envelope thing for a future detector type of.
I mean, what is the what? There's a lot of conspiracies and all kinds of stuff going on about them.
Stuff was cool. I wish. See, this thing is these conspiracies. They're never like. It's always just not as cool as they make it sound. And
what are they doing?
They're just colliding like particles, right? Like you want to send things in at higher energy so they get close enough, and then you can start to see the structure of the thing. So imagine like you have like this bag of quarks, and you start to see that like the kind of component nature of your like protons and things like that. It's just you're colliding, and then you're trying to measure what's coming out, and you want to like try to infer how your theory of the interactions is consistent with that.
What is coming out?
So I mean, it should be jets at some point. These things hadronize. Oh, sorry. So like basically, you're colliding. Say depending on the collider, you're putting like say electron, positron, and other colliders. And this is like say two protons are colliding, and you're gonna have the protons are made up of some like quarks, and then they're gonna have some interactions, and then they're shooting out other quarks. But like there's other particles in your standard model field theory. And those interactions will determine, I guess, the rate at which different things are produced. And so there's a theoretical thing you're modeling like those very short distance scale interactions, and then you're trying to infer from the energy deposited or like different particle tracks that this thing is actually what happened to then say something about your theory. And that's fun and that's cool. But the scary thing is just how big, like how hard it is to like probe those high energy scales. And you see these huge. I mean, the collider itself is like. These rings are amazingly huge.
It goes around 3 countries, right?
Yeah. I mean, well, they're near a border, but yeah. But yeah, so very interesting engineering feats for fundamental physics. And that's cool and something I probably didn't appreciate as much as I like because I went into theory. I obviously somehow didn't appreciate it enough. But yeah, it's cool. I don't know. You end up knowing so little compared to all the things you wish that you knew about the stuff. But
Is there any truth to the fact that they're trying to create some type of a black hole?
They're not trying to. No, I think that so that was a fun thing to see. I think I finally met one person who is kind of this back of the envelope fear monger fun guy for the billionaires. You know, like because I can understand like I mean if you're coming from a defense kind of point of view, you want to understand the risks or whatnot, and I'm like. I wish it were that fun. I wish it were that risky. Like, nah. Like if we were, I mean, I'd love to be like building wormholes, but they're not going to be like, you're not going to be able to transverse anything. No. So it's so sad. This is the no-goes that are the worst thing. Like I mean,
I'm just curious because it sounds like now you're really into black holes and you're.
But I spent most of like my childhood convinced that like there was cool stuff that could be done. And then most of like learning grad school or end of undergrad to grad school the hard way, it's not that cool. And then being upset at the fact that all these people overhype things and like, it's not as cool. Quantum computing is like way overhyped. And then suddenly AI actually is useful. And you're like, holy shit. So I don't know where I should land in the end or what I should learn from the fact that like, yeah, completely disillusioned to like overly enthusiastic in a couple of weeks.
How long were you at CERN?
Oh, just like 2 summers, like whatever like less than 90 days or whatever for the work permit. I forget now, but just 2 summers.
I mean, what's it like there? What's it like when you walk in? What's in there?
It looks like old buildings. Like I think that it's a bunch of. The weirder thing about it is the way that it interfaces with, say, the U.S. institutions or things like that. You'll just have a lot of like. I don't know what year, like 50s or something. They look like dated buildings, but with a bunch of people in offices. And then all of the cool, expensive technology is in the actual like detectors, say. So it just kind of looks like, I don't know, like what you would imagine probably some industrial complex thing. It's a vibe.
Is it, I mean, do you go underground?
I wouldn't for what I'm doing, but sure, I would for a tour or if someone was actually like putting together detectors, absolutely, yeah.
They do tours?
Yeah, they do. Yeah, when it's not running, yeah.
I gotta check it out.
Yeah, they got a hard hat.
So how do they get two atoms to collide in a tube?
This is way above my pay grade, but it's a bunch of magnets accelerating these things to like higher speeds, and then I wish I knew. I should literally I should probably know detector design, but luckily I'm not technically studying the manufacturing of or like engineering of the things to test the experiment. I'm like purely in the theory side.
Do you see when the particles hit?
So they would see the tracks afterwards. So that's the funny thing too, is like you're not actually seeing you don't see the Higgs boson. You're seeing like the fact that the things that came afterwards are consistent with it being there. And I think that was a kind of funny thing too. Again, very silly, but maybe visceral in the sense of like you're not actually seeing the thing, you're inferring the thing. Versus like for gravitational waves, it really is like it's a sound wave where they're seeing the the mirrors move apart, and that's kind of fun. It's fun when it's they're actually seeing the thing they're saying instead of indirectly inferring the thing.
Interesting.
Post processing is
what does that all mean?
To each their own. I think that what it means in some sense is like you've tested a particular theory, and so you're kind of ruling out some parameter space of, okay, there's no super partners or things like that too, or we understand this Higgs mechanism.
Did you say super partner?
Oh, so like basically I think that at some point a lot of people were looking for like extra particles that would come if there was this like symmetry relating fermions and bosons. So things that want to like be apart from one another, like you only want to like fill one in each state, versus things that like to kind of cohere or have like amplify each other. Sorry, that's a bad analogy, but there's two types of particles, like integer spin and half integer spin, and some people were trying to conjecture that when you build these colliders, you're going to see more and more particles, and then that'll change the way that we think of these frameworks being organized and things like that. But turns out maybe not. Maybe we don't know when the next like new discovery is going to be. And so it's weird because then you're trying to fund an experiment where you don't know what the answer is going to be, and you're like, how expensive is it to motivate or to build this thing?
Wow.
Yeah. But luckily, I'm not as involved in that. I'm like purely theory for the sake of that way I can be decoupled from these like high cost experimental ventures for a bit, and then just tackle that problem of kind of like mathematical, I guess, induction or something on the theoretical physics corpus, I think is one way we say it.
I didn't really think much about skincare before, but after enough long days, travel, and stress, you start to see it in your face whether you want to or not. That's what got me into Caldera Lab. It's a straightforward routine built for guys. Nothing complicated, just a few steps that actually work. I use the good and the base layer. Takes less than a minute, absorbs fast, and has no greasy feel. But the difference is noticeable. My skin looks healthier, more even, and just more dialed in overall. And it's not loaded with junk either. It's made with clean, clinically backed ingredients and does exactly what it says it will. It's one of those small habits that adds up over time and changes how you show up day to day. Give it a shot. Go to calderalab.com/SRS and use code SRS for 20% off your first order. That's calderalab.com/SRS. Where do you go from CERN?
So from CERN, I use the fact that it's easier to get into grad school via experimental things to get into grad school at, like I went to Harvard at MIT grad school options. I went to Harvard because it would be more easy to pivot, I thought, because I'd already worked with the people at MIT. And then at Harvard, I think it was like quantum computing or string theory. And I thought that quantum computing was overhyped, so I picked the other one. And I don't know how people feel. Like string theory was so cool back then. And it was like, Brian Greene was very much making it cool when I was a kid. And I still think it's super cool, but it's not for the same, like almost for the same reasons that people sometimes hate on it a little bit. Yeah.
So can you give me a dubbed down version of string theory?
Maybe. Okay. So you're basically, quantum field theory is giving you these fields that explain why particles are identical, because they're like the electron is just an excitation of this field. So like I have multiple electrons, they're excitations of the same field. You can think of, say, the mechanical process of how I'd compute some amplitude, like these predictions for CERN, as a bunch of world lines coming in with some rules for how they interact and split off and create other particles. String theory is kind of chubbying out this like graph to like a sheet, kind of like a literal like a pair of pants, say, so interacting, and like you have this world sheet. So what it does for you is it kind of two things. Like one thing is it kind of opens up this UV behavior. So it sort of points, it's kind of just like this branching of like a tubing thing. And then the other hand, it also gives you a particle spectrum. So basically it's like, you can imagine, okay, let's try to build some mathematical framework within which I have the spectrum where I have this graviton, I expect this gravitational field. And then I avoid some pitfalls of trying to treat gravity as a quantum field theory too. And then people just keep building off of it. And then there's years and years of papers that you're like behind on when you're a new grad student. But the main idea is trying to find some underlying mathematical framework that can let you have, you know, your cake and eat it too, like gravity and a quantum theory.
Okay. All right. So we go to Harvard.
We go to Harvard.
Get your PhD.
I'm working on my PhD, and I think the whole airplane story, I have a bunch of friends who are like in aerospace who think, oh, this kid's cool. I'm doing some fun research with Andy and friends with spin memory effects, stuff like that. And then you get overhyped really quickly because, you know, any press is good press if you're trying to start a company, but not if you're trying to get along with the 2,000 people in a field that, like, you know, are sometimes bombarded by like, what is string theory doing, that type of thing. So like very much closed ranks type of thing. So that happens in the middle of my PhD. So I guess I'm lucky that I didn't take all of these advanced grad courses and just took a lot of E&M for like some of the stuff that my advisor happened to be doing was very like, you know, you have a charge. When it accelerates, it radiates, kind of like, you know, when you have an antenna, like you're seeing like the radio signal from some charges moving up and down antenna. So it was very easy math compared to a lot of stuff that people do in my field that I could latch onto and then think of some sort of fun little experiment. Well, not real experiment, more like a thought experiment type of thing of how you'd measure angular momentum loss in a spiraling binary system, say. So I have a fun result pretty early on in my career, but it's like, it's a lot of luck that, like, you know, if Andy's on the paper, then people care and people will write about it as spin memory effect or something, versus it's like, so you get a little bit of like, that's cool. I'm lucky in hindsight. Very much love the kind of way that sometimes ideas can come together really quickly. And then other times you're wasting a lot of time just being stuck. So I'm lucky to have some good experiences at the beginning of my grad program, but then I get hyped up in a silly way with this Einstein bullshit. And then I'm like, ruh-oh, because my family thinks it's awesome, you know? Like, I mean, yes, when I was a kid, if I was going to be a physicist, wouldn't you want to be like an amazing physicist? Like, of course, that's the goal. You go to Lindau, you go to these conferences where all these Nobel laureates get to hang out and you're the students who get to meet them. And you're like, this is the life. I mean, maybe not exactly like, I think it's better if you earn the money and then you whatever, but like there is a lifestyle to like just being good at your job would get you. And it's like, I wish it were real, you know, because like hype will just go away at some point. So I got a taste of the dark side with that, but also seeing just a little bit more of the sociology of why do people like this like narrative of like a individual doing something cool, and how does that fit into the fact that within our field, the people who write like popular science books are not necessarily ostracized, but it's just like, it's distanced a bit, and then it's hard to work with them. So like, it's funny, the people that you see as the physicists publicly are like not the real physicists somehow.
Interesting.
And I think it's just funny politics almost, or you know.
So you want to be under the radar. You don't.
No, I don't. No, I mean, I am ego. I wish I did. Like, I wish I did. No, I want to be for the sake of wanting to do well in my job. I need to be, right? I don't want to be above the radar as a physicist in the sense of like, I don't deserve attention as a physicist, right? I wish that I did something cool enough where I felt like this wasn't complete, like whatever thing. But I do think what I want is that there should be a way for, you know, the fact that, you know, people care about science is good. Like, how do you better kind of link together like the folks who are good at outreach or the folks who are lucky enough to have opportunities to have outreach and the research in a way that benefits the research, is best for like the physics. And I'm excited for that being something that we can change now. And I think that maybe, I don't know if it's because I'm faculty now or because the times have changed with how science is funded, that people are more open-minded to, you know, a little bit of like being creative with how you interact with industry, for example. Gotcha. And that's exciting to me because that's like things can get done a lot faster when you're not just in a group of people who've all decided this is the way it's done.
Gotcha.
Because it's been like that, yeah.
Where did the Einstein analogy come from?
I think it's just some Aussie article trying to be flashy and it was good clickbait. I don't know. Like, I mean, to be fair, like you wouldn't use those words. I mean, you are studying gravitational waves and then people just try to be nice. I don't know if it was a girl boss time of decade or whatever, 2016, 2015, 2016, I guess. So that stuff, I have no clue. I'm pretty sure like you don't see the articles before they come out. And like, I didn't want any ridiculous comparisons because mostly, you know, airplane build kit stuff probably makes it a cool story. And then you're doing fun stuff with, you know, top people in the field. And sure, Hawking starts like to work on stuff with Andy. So there's that part of it too. And Hawking is one of the few examples of somebody who is like known for their research and their outreach and like actually really good at both. I think it's rare to have somebody where they're popular and they did really cool stuff. Penrose is another example, I'd say. And I'm sure that there's more that I could start listing, but it's rare.
Elon Musk.
See, that's the thing. He was my hero as a kid. And then I went through different phases of how I feel about the guy.
What?
No, I know.
Let me hear. I got to hear this.
Okay, so when I'm a kid, and this is me being very, very and not realistic, but like I'm in high school and I see like this like Quanta article about Tallulah Riley taking like physics courses at Caltech. And I'm like, she's not a physicist. She's just taking a few physics courses. I could do better. Whatever. This guy thinks, I mean, I'm like, I'm a kid. So this is dumb. But I was like, these guys like physics. Damn. But I didn't understand to what extent they did. So like I saw him as somebody like closest thing to an Iron Man in the sense of build cool shit and get people to build cool shit. And like I thought if I were in his shoes, I'd do the same thing, right? And then you see like you start getting a little shaky of like how much does he actually know how to do? It's like, you know, how much is the team behind him that's really holding it up, and then how much like I thought, okay, if I like get the PhD or something, I'll be the actual expert to then be able to be more legitimate in a position where you get to do cool stuff. But I think that's the kind of wrong attitude. So I went through phases where I was like very disillusioned with the fact that he kind of represented science or tech. Like people believed whatever he said was like right, and that he also was the engineer and he also was all this stuff. Not saying he is or isn't, but I'm saying like there was definitely this sense in which there's no way he's actually doing all this stuff because I see how hard it is for people to do all these things, right? And then you get over it or whatever, and you realize how, you know, there's a lot of value to being able to get other people on board with the same vision, because then you can really push for it. And as long as that push is to something that's possible, then you're good. If it's a push towards something that's impossible, that's scary. And I think that was something where, again, before the AI stuff, I was very disillusioned and being like, man, they're like taking buzzwords and concatenating them with like quantum computing and what else was I disillusioned by? Like, you'd see things that as a physicist, you know, like there's certain no-goes and they're still getting funded. And you're like, like, you know, like we don't have like this lack of vision. We wish we were doing cool stuff, but like somehow we can't, you know. Now I think that's changing. And at the same time, these people are just overselling things kind of adjacent to what we do and acting like they're going to be better because they're entrepreneurs and like, when we don't know what we're doing. And I was almost resentful of that at some time. But I think the coolest thing now is like, damn, like the products they're building with like Claude Code or whatnot are super useful in the sense of, you know, as a physicist, not many people in theory know how to do much more than like pen and paper, use Mathematica, whatnot. If I wanted to like think about questions that are more like systematic, like you just want to like compute all of these different things numerically or whatnot, those are not valued because their field is so small that one person doing it would be considered a waste of time because they're not going to have a chance of getting a breakthrough. But you know, when you have tools that open up your ability to basically like, instead of hiring a dev team, like you don't need the resources for that. You can still like just do it yourself. That's really cool. So I'm like super grateful that maybe some of that hype led to technology that's actually useful for my job, or at least the things that I wish my job were. So I think my opinions clearly oscillate a lot about some of these folks. But yeah.
What do you think? Do you think we're going to make it to Mars?
So I think he could make it to Mars, depending on his definition, right? So like, I when I was a kid, it was really almost grim or like very pragmatic. I was like, you just want to get to Mars. You don't necessarily need to like come back, right? So like, can you do like the first person to go to Mars one way could bring a bunch of like genetic material in a little arc and have it like cryogenically frozen out. Now I was thinking like send them one way. So I think someone could get to Mars, absolutely, if they change the definition or the scope of what their goal is. But yeah.
How fast do you think we can get there?
Oh, I'm not going to be the expert on that. I think that I definitely would be parroting things when I was a kid, like off of what other people were saying. And I do think it depends what you want for it. Like I always thought, manned missions were cooler than automated missions. Like the vibe was cooler, but it does make sense sometimes to not risk, life and limb for no reason. I do think that, yeah, I think it depends what the goal is. I think like I'm open-minded for getting around red tape to do something cool. And again, I kind of also, I really liked, like, it's weird because I think that like I had like secondhand sci-fi because I never like read these sci-fi books growing up, but all of like the people I admired did. I still kind of like the Earth. Like I'd rather if I had the same resources, it probably would be more like less aerospace now. It'd be more like infrastructure, like trains and things like that. Just like a lot of things you can do that people would care about terra firma. But yeah, so, but it's funny because it can align like your vision a certain way. Like if you want to get to Mars and you think, oh, I need some sort of like invention to do that, then we got to like build this AI to be smart enough to help us figure out how to do that. And then we need to like, you build the AI to also figure out how to solve the energy problem so that we can scale it up the right amount to be smart enough to do that. I don't know. So like, it's a kind of funny thing where you can use the end goal to tell you how to get somewhere. And so maybe he's used that, or maybe it's just a good marketing scheme. I don't know. But yeah.
Do you think we're going to need to go to Mars?
I mean, I think I don't feel that existential like need the same way in the sense of like the point where you need to get to Mars if you're not already able to go there. Like try to avoid that first maybe. And you actually would have more expertise on that side of things, how scared you are about like chaos and
I don't know, man. I always think the world's ending.
Yeah, but like that's a bias that you'd have. I mean, I'm sure that's like they have to get you like trained to save it, right?
Yeah.
Right.
I don't know. But who else do you look up to, did look up to?
I mean, I looked up, different parts of lots of people, but like at the time when I was a kid, it was because, it was Virgin Galactic, Blue Origin, and SpaceX were the ones who were kind of the big players in this private aerospace industry. And they were like, whenever any parts of their companies were at these air shows, like that was the cool stuff. And I like this notion of trying to make profitable or build something that wasn't necessarily its best value proposition wasn't so much the capital that it could get, even though you try to make it self-funding or something like that. Like I like that kind of encapsulation of doing things. Because I think like, for example, theoretical physics research, you can have a lot of YouTubers go around and debate like, why is the taxpayer funding this? Or is it stagnating? Da, 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 da. And it's kind of missing the point that like, okay, so say you defunded like this subfield, who's going to actually know quantum field theory amongst the people who are doing data-driven stuff that doesn't like, that's making progress now. So it's like, how do you take advantage of the fact that like there are things that are worth funding that are not necessarily like worth funding because they make money or because they have a product, and then try to align it in like a kind of maybe not corporate structure or something where you make it so that it doesn't need to rely on things like always having been that way. Can you innovate in that space of trying to fund or have self-fund valuable enterprises that are not driven by profit, but driven by the thing that they're after? So whether it's space exploration or like solving physics or something like that. I'm inspired by that a lot.
Who's doing that?
I mean, I hope we can do it. No, I don't know. I see, the thing is right now, it's this funny, we're at an interesting time where I think like the technologies that like everybody cares about, AI, whatnot, really can help doing the job that I do. Mm-hmm. There's a thing of like, I don't know how to make the right pitch for somebody who believes it's going to do everything, and also conveying what exactly it means to solve physics or not. So like in practice, like I do think there's a sense in which like we're trying to axiomatize these laws of nature, and maybe there is some uniqueness or rigidity to that structure that it can find. But I think that a lot of people think, oh, there's a particular open problem and it's going to write a paper that the researchers are going to be like, whoa, this is better. And that's what physics research is. So I'm scared of like not having a good like collaboration, say, with the industry folks and the academic folks to really kind of pin down, okay, say you can accelerate science. Did you finish it? Or did you now open up a new chance to build more infrastructure for how like that knowledge is stored and related to one another?
Interesting.
Because we don't just want to answer about, like, I think that if I was an engineer, like I want to know the answer to like this math, like this equation to like predict what I would need for my engineering problem, versus for physics, it's more like, okay, here's the answers, but why? And really just distilling that, kind of compressing that basic set of rules that lead to that why. And so I'm scared slightly that like, if this field is stagnating because we're only individuals doing something and we can't make our field very modular as it is because of just like historical precedent or whatever the number of people is, That when somebody comes along and actually does have a result that's better than these things, is it like, oh, let's just put all our eggs in one basket now? Like, this is the better bet. And I think should be a fun collaboration. And I think that the nice thing now is that there are a lot of some crossovers with people like spending sabbaticals at these big tech companies, and some care about research, which is great. But how do you make it so it's not just like, I think I like academia in a way, I don't know, it's institutions, right? But can you try to use the fact that there is some value proposition or exchange there to like try to drive like innovation for like, try to get the best product that like can do theoretical physics well. Maybe I'm using other people's products or whatnot, fine. If there's any IP or value in that, use that to help fund a field going forward instead of it being relying on taxpayers, whatever, for a very specific, small, like highly purely theory thing. Because there's value that can come from the engineering side of it. So, for example, when you build CERN or you build these other like big detectors, a lot of the time the value proposition isn't, okay, we're learning something about the laws of nature, which is cool. But it's also that all of the engineering that's going to go into that is going to be super valuable. Can you do that with theory? And I think that now the answer is yes, and maybe it's already being done in some sense, like when they're selling intelligence and they're getting like fundraising for those companies, maybe that is the pitch and that's what they're doing. But I find it fascinating to be I feel like we're back at this like moment when CERN helped invent the World Wide Web. Like, can you, instead of like whining and begging, like, oh, we should have like had better structures that like endowed like a field or something like that. Maybe it's not even the right thing to do. Can you do that now without like begging for things to have been different in the past and just like, there's opportunity now, go for it and do it right. Don't just care about papers, care about some of the infrastructure,
CERN helped build the World Wide Web.
I mean, that's what they say. I hope I don't get all the facts wrong, but yeah, like they have a lot of data and they're wanting to like serve it to different places. And I think DARPA gets a lot of credit too there for actually like what you think of as the internet. But, like when I used to, and this was the type of thing that bugged me a lot, because I think I had these heroes in tech that thought like, oh, if the physicists maybe just did things differently, they'd have like all these whatever cool thing. And then you walk into the door of where I worked and there'd be a thing on the side because it was funded by a tech person of like saying how, quantum mechanics like leads to like the transistor technology, and like understanding general relativity helps with like timing of satellites and GPS. Like imagine if you had quantum gravity, or like the blue sky research you do now might lead to something cool in the future. And I believe in blue sky research and it's great. But I think the thing is like, normally it's still, there's a reason for it, and like, how do you, like, it's a weird pitch to try to say, oh, it's worked before, so keep giving me money now. It doesn't feel honest. I mean, it's, in some sense, yes, but like, I didn't like that. I think the cooler thing would be, again, to try to see, like, how do you align things that are valuable with the thing that you want to do as a physicist and like go from there? Because there's anything that you want to be able to do, if you can't do it already, there's something missing. Mm-hmm. And it probably, if you're a human interacting with it, it's an engineering thing. It's a product you could build and not like an equation you're trying to solve. So I think that's a fun thing that's kind of opening up, probably because of the way that like funding is weird in academia right now. Like, can you decouple this? Like, we basically view universities as just educational institutions until you go to grad school and you realize it's a research institution. And like all of the great grades you get in undergrad, you realize like they don't care. They just care about their research. This is not that. This is like some way the U.S. like is basically funding private institutions to do research at scale. And the overhead seem crazy, but that's just how they fund it in Europe. They'd be funding the schools more directly. So like there's such a dichotomy between, I think, how I used to see MIT or Harvard before I went to grad school and how I see it now, of like completely different value propositions or priorities in the institutions. And so like, how do you make sure research gets funded and is super cool? And it's maybe like that the experts in the field are the ones deciding like how the resources for that field are allocated, rather than it being kind of, okay, these institutions get money from revenue streams from teaching students. So it's like the best people in different fields all in one, or big tech says, it's broken or whatever. Like, come into our private lab, yeah.
Wow.
Yeah.
Wow.
We'll see. Oh.
Let's take a quick break. When we come back, we'll start getting into space. Most gear looks good until you actually start using it. Then you find out pretty quickly what holds up and what doesn't. That's why I keep coming back to Roka. These aren't just lifestyle sunglasses pretending to be performance gear. I've worn mine training, on the range, traveling, and outdoors for long days, and they stay locked in place the entire time. They're incredibly lightweight. The optics are razor sharp with zero glare, and you honestly forget you're even wearing them. But they still look clean enough to wear anywhere. Not overly tactical, just modern, functional design that works every day. Roka was born in Austin, Texas, and everything about them reflects that performance-first mindset. And if you need prescription lenses, they offer both sunglasses and eyeglasses options built to the same standard. And whether you're outfitting a law enforcement unit, a military team, or looking for corporate gifts that don't suck, Roka offers wholesale partnerships to make it happen. Roka isn't just eyewear, it's confidence you can wear every single day. They're the real deal. Ready to upgrade your eyewear? Check them out for yourself at roka.com and use code SRS for 20% off site-wide at checkout. That's ROKA.com and use code SRS. Welcome to Hollywood versus reality. They do it, right? What does he do in the movies? Tell me if I'm doing this wrong, because I don't watch any of this shit. Little flick like that, right? Seems pretty cool. It is pretty cool. Gotta silence it. In another lifetime, I did gun reviews for a living. Proprietary magazines, supposedly the best engineering in the world. When that breaks, you're and now we're bringing them back. It does look pretty cool. I gotta admit that. All right, Sabrina, we're back from the break. We're gonna get into your current work.
Okay.
Gravitational memory effect.
Yes.
I need you to slow down just a little bit for me. I'm not on your level quite yet. Maybe by the end of the interview.
I just talk fast. Yeah. So
What is gravitational memory effect?
So there's different kinds. The easier one is not the one that I came up with. It's much older. And it's this notion of you're going to have these big bodies out in somewhere in the galaxy or whatever, or far away, coming in and colliding. And then when they collide, they're going to coalesce maybe into like another black hole or whatever it is. But there's some ripples in the space-time that come out to you. So these gravitational waves are propagating away from this collision event.
So this is like indentations in the weave of space.
Yeah, roughly. I mean, I think actually it's pretty accurate in the sense of like I'm looking at like, say, at a given time, the positions of some mirrors that have been moving back and forth. So the thing about the memory effect is basically that there is like a very like long time scale thing that's imprinted because of this scattering process.
Can I make another?
Yeah.
Would this be like the wake of a boat?
In some sense, almost literally. I think that the thing about the wake of the boat is there's different approximations for like a deep water wave, and like it's not as universal. I think like I have a friend who has a family who's like into like nautical stuff. So I think we concluded that like that there's a sense in which sound waves in the water could be approximated as having a memory effect, like if they're deep underwater, but like a surface wave is not going to have a universal relation between the boat passed and then it moved. But okay, so imagine, let's do the buoy analogy. So I don't think the math works out the same, but imagine you have like some boat passing and you knew that like you could infer like the amount of like munitions on this boat because like the buoys moved a certain amount. No, like, you know what I mean? Like some net property of like the thing. So it's not as cool as that, because I think that in that situation, it's not a universal relation between the things that scattered had some kinematics that then set the value of this shift. But yes, you have these two gravitational like wave detectors, some probes sitting very far away, just minding their own business. They're sitting along geodesics. This wave passes, and then the distance between them is going to change.
Okay.
And like depending on where they were relative to this thing, there's a certain like pattern in the sky that it would, and you're seeing that there's a relationship between this distance changing and like the kind of net kinematics of the amount of like energy in the things that were scattering and the waves coming out. And so there's this relationship that's like conservation of energy generalized to this kind of fun asymptotic symmetry version of it, turns into deterministic imprints in the night sky of these move detectors. And then to see the angular momentum analog, you have to go a little bit subleading, which is the spin memory.
Oh,
effect.
shit. Okay. I think I'm picking this up. So, So you're saying, okay, how do I explain this? Okay. So if we have a sheet or a blanket or something, and I put, I don't know, a mark on here and a mark over here. And then we put a ball in the middle.
Move a little bit.
They come inward.
But
is that what you're saying?
It's like, so that would be kind of an analogy for like maybe like the just gravitational like potential kind of curving you in. I think this is closer to the buoy analog. So the math is wrong. This isn't true for this case, I'm pretty sure. Of like, imagine that you could have some buoys pretty far away and you knew that there was always a shipping route where they go like from here to there. And like the only options are like the direction in which they came and like maybe the momentum of that boat. And you could infer from the buoy shift those types of quantities, regardless of whatever they did in the middle. So that's not going to be true for the water wave. I'm pretty sure it's not true for the deep water wave case. But for this gravitational system, there's a symmetry reason why I can see that type of shift. Like the buoys move by a certain amount, that means blah, like this amount of energy was deposited, like type of thing.
Okay. So does the imprint stay like that in space?
That's the whole point. So this is supposedly like at the very end it stayed. Now in practice, that's not super useful because like we do these things where we have a theoretical framework where the math is rigorous and then it's completely BS in the sense of that's not the thing you're going to measure. So like in my framework, I'm viewing that single whatever ship crossing type of thing as the entire everything that happened in the whole world, infinite amount of time. But what you do then is you say, okay, there's this effect that this framework studies, but it really is only accurate for like each individual scattering experiment is like a chunk. And so there's a shift from that scattering experiment. And sure, something else is going to move it around later. But if they're spaced out enough in time, can I approximate this thing as like the memory effect?
Okay. So let me re-explain this to you to see if I'm getting it. Yeah. So basically what you're saying is that it will leave an indentation, an imprint in the fabric of space.
Yeah, exactly.
And it will stay there forever until something else moves it.
Yep, something else moves it. And then there's a very formal version where we say, imagine you wait for an infinite amount of time. Tell me the beginning and the end. And that's technically the memory effect. But in practice, it's closer to like, let's pretend there was just one thing that happened, one thing you're detecting. So one event. And as far as those timescales are concerned, it's a lot longer than any other thing later moving it.
Okay.
And so then that's a memory.
And you discovered this?
I discovered a variant of this based on the connection to these symmetries.
What is the variant?
So this variant is like angular momentum loss instead of energy loss in the gravitational waves and the spinning particles kind of. So basically it's like, and this was a kind of fun thing. So I come into my PhD and you're almost just going to do like classical radiation. So like, you accelerate a charge, it's like emitting radiation. And the fun thing about, gauge theories, so gravity and electromagnetism kind of fit into this framework of the, there's an extra symmetry when you try to write down a field, like a set of equations that are local. So what happens is that one kind of effect, like when you have a charged object, so say you take some cat and you're like, I don't know, like some riboelectric effect thing to get some charge on like the fur. You like static electricity or these things where you see like this balance of charge, you probe it far away, right? So I can, with gauge theories or with like these, like the fun thing is I can be away from the charge and see it. So I don't need to come up and pick up, oh, look, I have like an electron charge. It's like I can see the electric field is like pulling me in, like you were saying with this blanket and like the it being deformed. So like I can measure some features of this object in the center from the boundary. And that's kind of one of the ingredients to this kind of holographic principle of like, can I just talk about the things in the boundary in isolation as its own theory? But for the very specific scope here, it's like that Gauss law type of setup of, okay, if I am very far away and I measure the electric field everywhere in some sphere, I can determine the total charge inside. The analog of that when I then have an accelerating like scattering experiment is kind of like this imprint of this universal, like I know from this low energy part of the radiation, something about the kinematics of the charges scattering. So it's like Gauss's law, but applied to some scattering process. So like,
what makes the particles scatter? Is it a collision?
It's their own interactions with each other. And that's the funny thing. It's these long range interactions that are busting and occur. So like the fact that they're charged and then they're going to like have some photons exchanged between them or other particles is the thing. But we basically like, there's something about the very low energy that is universal almost because of these classical equations of motion. So I guess long story short, when I do this idealization where I pretend I'm in flat space, that's my world, and I want all of these solution sciences equations that obey these boundary conditions, then I see that, things at the boundary are going to move. So like what you're saying is I have like these two detectors are sitting there. They're not just going to stay there. They're going to move, but they're going to move by a certain amount that's maybe a certain like controlled parameter as compared to where they are if I just push them out to infinity. And so like, because you have this kind of whole symmetry framework that you're importing from other instances where it's been useful in physics, you can apply it here and you realize, oh, look, that tells me something about soft limits and scattering. It tells me something I can observe. Yeah. So early in my PhD, they had this connection between like soft physics and a asymptotic symmetry word identity. And then my first paper was on like the subleading soft version of that, which was new. And some people had speculated that there might be a enhancement of the angular momentum, like the rotation symmetry of the world in some sense. And then when you keep pushing that further, then you can tie it to this experimental version because someone else understood that there's a physical, like the space-time physical thing you're measuring is related to the waveform that you're otherwise computing with this quantum field theory computation. And yeah. So anyway, basically, long story short is you were just taking some mathematical framework and then trying to copy paste it to a new application once you have like one iteration. You're trying to see what's modular about like some computation. And then you get to import that and find something new because you pulled it out.
Wow.
Yeah.
Wow. I mean, Stephen Hawking cited your solo and joint papers in 2016. Your dissertation is only the second Harvard physics PhD published in Physics Reports. The other author won the 2004 Nobel Peace Prize.
Yeah.
That's incredible.
Yeah, I mean, yeah, these things are fun, but it's always fun that you probably find a way to find a cool little way to frame what happens or not. But the Hawking's thing was cool because again, he visited at the end of like near the end of his life. He came to Harvard, which was neat to see. Just the entourage. Like we were we were on a Congo line in this boat, like kind of like those like little river cruise type of thing, but in the Boston Harbor that was like Hawking his whole entourage. And I was like literally doing like a little Congo line behind him. And like, I mean, you can't you can't make that up. You know, it's a fun experience. So,
So what does this discovery mean?
I don't think it means that. I mean, it means I'm lucky that something experimental is going to come out of like something I did. Maybe I don't think the things that I've done have like that deep of a meaning or something where like everyone should know these types of things necessarily. It's more like the fact that there is some value of trying to take these frameworks that are very abstract and try to distill parts of it that then you can try to then push for the more realistic versions of it. I think that's a fun kind of paradigm, and it's like fortunate that there was some observables of this. But at the same time, like I'm using Einstein's equations to get it. It's more of a test of like the boundary conditions being a good physical assumption than a test of the theory itself, right? So I think that it's not like super, super exciting. It's exciting to me, but like it's not like, I wouldn't say tell your audience is important or anything like that.
I think it's pretty cool.
Lots of things are cool though. Lots of things in this building pretty cool. So
Is the universe expanding?
So again, I think that that's a funny thing. I do think if you talk to a cosmologist, they believe in like the cosmological constant, like isn't necessarily being actually like, sorry, there's this experiment right now that's like trying to promote that maybe the cosmological constant is like changing over time. And a lot of string theorists love that. A fellow, like a faculty member when I was in grad school at Harvard, like Rafa is kind of colleagues with Andy. He is very into the Swampland program and trying to test things. I think that I am not too into the experiment to know like why a lot of cosmologists don't trust the results yet or whatever. But I think that a lot of things are up in the air in the sense of, like there's always qualifications to things. So like, it's good to at face value trust the actual result of an experiment, but you want to understand what are the extra, like, what is it actually seeing versus what you're actually over-interpreting it as seeing. And so one option that a lot of people like is, okay, maybe the cosmological constant is changing over time and then it'll be asymptotically flat or the wrong sign, opposite signs to be where string theory likes to live. So I guess I end up being very agnostic in a weird way, which is not good because somebody should just answer and say, blah, this is our model of lambda CDM.
But it is true that stars, galaxies,
sure.
apart,
Sorry.
right?
So there's a sense in which, yes. Like, so I think what I'm saying is I'm taking it to be like, okay, you're looking at these various stars far away and okay, so the fun thing about physics is you're often saying the laws that I have here are the same everywhere. So if that's true, I know like some features of my star or stellar formation. So I know like the spectrum of the lines that are supposed to be there. So if it's moving further away, I'm going to see like different frequency shifts and things like that. So there's a lot of cool stuff that you can see where like, yes, that's not in doubt. I think the thing that I latch onto, because again, like it's close to this, like, is your framework even physical? Is like the statement about like some parameter, like the cosmological constant in Einstein's equations, and whether everything I do, I'm like a flat earther as far as like cosmology is concerned, because I just set it to 0. And like, now there's some experiments saying maybe that's okay. No, but not. But like, what things are constant versus functions of other things that can change over time, roughly. Yeah. So,
I mean,
yeah.
We got to
Yeah,
get
but the expansion thing, sure.
You're
like,
not a flat earther.
I'm joking. So I don't want to encourage a flat earther. Sorry. So like, you know, like, sorry. So the extent to which you're on the Earth and you see like the curvature scale of the horizon or whatever, you're not seeing it, and you're saying, the world is flat. I'm just trying to make a joke, and probably it's dangerous to do it at the actual platform, of the fact that like, you know, do we see the curvature scales of like the universe, the cosmological constant, at the scales where I care about it for particle detectors or for these gravitational waves from LEGO? And I'm always setting this constant to 0 instead of like whatever, 10 to the negative, like large power. Like,
so if the universe is expanding,
yes.
or
Yeah.
or if we want to say the galaxies and stars are getting farther apart.
Yeah.
I mean, I feel like that means the universe is expanding.
No. Sorry. I'm not saying no. I think you're right. But I'm saying that the physicists are worried more about like, why is it, right? Like, is there a reason that there is some like various like cosmological constant there, or like, is it all just like the different like matter distributions and things like that try to govern the reason we're doing? So I should have just said, yeah. But instead I was like, oh, by the way, there are experiments that are like maybe like, you know, changing our opinions a little bit or calling into question some notions of those like parameters that describe this thing.
So if it's expanding, what does that mean? There's a wall?
So that's the thing. So the fun thing about cosmology, if you're doing like a holography for like de Sitter spacetimes, is there is like a literal horizon where you can, like, as one observer, you're not seeing the whole thing. And so the world that I live in is like kind of understanding the mathematical structure you can attach to the kind of the boundaries of the space-time. And in most situations, like in the ADS context, which is this like wrong sign cosmological constant version toy model, or in the case where I do, like it's really the space-time boundary and not the boundary of some observer. And then you have to deal with observers, and de Sitter is hard for lots of reasons. So I just go,
So if it's expanding, wouldn't that, the fabric, the indentions, what do we call it? The gravitational memory effect.
Yeah.
Wouldn't that change?
No, it does. So you're absolutely right. And in de Sitter, like the types of like you're basically propagating a wave on a curved background versus a flat background, and it changes the form of it further away. And people have papers trying to talk about it, like memory on like the observer horizon in de Sitter, which is the closest thing. But the thing that's relevant is like, you want to think about like what scale is that important as compared to what scale I'm like seeing the wave coming from this inspiraling binary system. And so like, at least for example, a lot of things I do are also relevant to not the memory effect so much, but like these asymptotic symmetry stories can be applied to amplitudes. And there, what you're doing, you have CERN, and you have this collider, and like it's such a small scale where these things are interacting, and that the detector itself is considered to be at infinity. But it's not infinite. I mean, it's huge, but it's like that's hardly infinity. And so like, can I pretend or ignore that expansion for some things? Sometimes yes, and then sometimes no.
Gotcha. Yeah. Gotcha. Wow. We actually have a hot question here. It has to do with flat Earth.
Uh-oh.
You ready?
Good. Okay, yeah. I'm ready. I think I'm accidentally reading this.
Here we go.
Yeah.
Surveys have found that up to around 1 in 10 Americans say they agree with statements that the Earth is flat. From a scientific standpoint, what actually proves whether the Earth is flat or round, and not just in theory? What real-world evidence or systems make that determination undeniable?
Okay, I should have prepared more because I got the best. I don't know the best answers, but I would just say, like, look at the pictures from the damn like satellites or like people up in space. You can see the horizon. I mean, like what? I guess I don't know why those don't work. For example, you know, when like if I talk to someone who was a flat earther, what would they try to say if I said, you know, look at the horizon, see it's curved, like, or go up on like a. Like,
I'm not a flat earther.
Yeah, I don't know.
But I've talked to a handful of them, and they always have.
What's the excuse that they use?
I can't remember what their excuse is. They think satellites are balloons that are not in space. I do know that. Okay. I don't know what the argument is. It goes on here a little bit more. Okay. Because technologies like GPS, satellite communications, and global navigation all operate as if Earth is curved. So what are the strongest proofs, and could any version of a flat Earth realistically reproduce those same results?
Okay, I'm trying to I would say no, but like I think what I'm saying, I'm trying to think of like how would I be the defense attorney for a flat earther? You know what I mean? like what would I try to do to make them feel as right as possible by caveating the hell out of everything they want to? I mean, like I think that you can't, once you're trying to say, like, I mean, you're trying to apply a framework beyond its scope of applicability, and that's what these types of technology or like the something far away above the earth is seeing, that it's wrong. But like, you know, to their credit or not, like when you're on a map, like you print out your little chart, like you're not gonna go that far off, like when you're driving around town pretending that, you know, the earth around you is flat, unless you try to park your car on a hill and you forgot to put your parking brake on. I don't know, like like basically. Like, no, and that's not for the curvature, but just for shits and grins. But I think that, I don't know, I think that it's emblematic of the fact that it's hard to believe the things you don't have input for. You know, like you build your intuition. We build our intuition, you know, walking around in a way where like you might not notice these things. Like, do you notice the like phases of the moon? I don't know like how much people pay attention to those things or how much it affects their lives. And then doubling down on that worldview is sometimes funny, sometimes scary. I don't know what the take on it is, but like, you know, there's value to questioning, I guess, like how much your assumptions or like the visceral world that you live in and the intuition you get from that actually extends beyond the things that you're able to probe yourself. Like you can't go and just jump up into space and look down and be like, oh, never mind.
Yeah.
So
yeah. Well, maybe soon though.
Maybe so. Maybe you guys send them up. Like, hey, they go free air. Like they'll say it to get on the free like suborbital flight or something.
Yeah. Follow up.
Yeah.
What's the biggest misconception people have about black holes? And is there anything about them that still completely breaks our current understanding of physics?
I think that if anything, okay, so breaking a current understanding, I think that sometimes it is the paradoxes that show that there are problems in our understanding. So I think that maybe breaking isn't as active word I don't think I want to use. I think that like, again, I always feel like I don't even understand these stuff well enough. And I think that's one problem when you're in a field that everybody's confused. It's like, how confused are you? Like when I say I'm confused, does that mean I'm actually confused? Or are you like less confused? Like who's relatively more confused? So there's these paradoxes that come from like basically trying to say, okay, I think I know, like it shouldn't be that ridiculous if it's a big black hole, like the horizon isn't that special. I only kind of know it like kind of like teleologically or like away from, like I don't know at the moment that I passed the horizon. So then why can't I put some quantum fields on it? And then like I have pair production, one of them will go out to infinity, the other one's going to go inside. And suddenly you run into these like issues of, like did I evaporate into a thermal system now? Is it not unitary and all this fun Hawking stuff? So I think the thing one should take away is that there are still, I think, situations where people don't understand all the assumptions they make, where they can just, you know, follow one step after the other, think that they're doing something that seems logical or not, and then they realize, oops, together something was wrong. And so it's not breaking physics, it's showing that there is something broken in our assumptions. Like it's not like the physics always has to be right. I think we believe that. It's just we don't quite know, again, like the regimes in which our assumptions are valid or which one is the wrong one. So yes, there's a lot of active things. Like some people, I think I still have colleagues who believe that as soon as you cross a horizon, there's like some like firewall or fuzzballs. Like there's like different models for what happens behind it. But we're all basically just playing with some frameworks, like mathematical frameworks that give us intuition for what we might guess. And then we're not precise enough with what we're assuming when we compute something. And then, these don't fit together. Like that's the vibe. But I think I wouldn't try to scare a random person with it. I would just point out that somehow the bread and butter of like a physical theory where you don't make a measurement is seeing that like these assumptions don't tie together. So something has to be wrong, then propagating it back and trying to fix it.
What is a black hole?
I think some sense like there's literally just a sense in which like I have so much matter in some region that now even light can't escape. And the way that I see it is like from a Penrose diagram, there straight up is just some region that I cannot access from infinity. So it's very much like a feature of the geometry. But then there's other fun things about like the fact that if you put enough energy in some region that you're going to end up creating a black hole. And that often is tied into this question of like quantum gravity has to be weird and different, you know? And so like, it's just, and it's neat though, because you see how much people like when they see, even though it's not actually the horizon, when they see like these images of a black hole and like the accretion disk around it or whatever, like generating the light, like engineering is cool. The fact that they can like reproduce that image or stare at a black hole. but like it literally is like a black hole in that picture, which is kind of funny, right? Like, like the way the light is bending around it. But I think that the fun thing is really just more like the way a physicist would at first encounter it is like there's a very specific solution to Einstein's equations. So there's a differential equation with a specific solution that then has some weird ass properties of like the causal structure of like where like particles are going to end up. So
What happens if something goes in it?
that's the type of question. So basically, I think a lot of people would believe, okay, when you first go through, you don't really know that you went through because like the black holes can be different sizes, right? And so like if it were large enough, the curvature scale when you're crossing the horizon isn't so extreme. But eventually, like if you just did like, little probes on this background, I think people talk about like spaghettification, or like you're gonna be stretched out eventually when you get closer to where the curvature is larger and blowing up at the singularity. But I think that's a funny thing is people like you understand this classical geometry and then you start having problems putting quantum fields on it and answering some fun like paradoxical type of questions that then people aren't sure, like they think that the singularity is something so highly curved that the approximation of just treating it classically is bad now. So then they don't know what happens, that type of thing. But it's not like, I think it's easy enough to try to say, okay, if I like have some nice numerical simulation and I can just write down this differential equation like for how something would propagate on a classical like black hole background, that you could have something just like going through the horizon for a little bit and probably like in that model it looks fine. But it's just like how valid are those? How hard is the numerics first of all to do near certain regions, and the way you set up for a scattering process probably is also hard. But it depends on like basically the problem is that sometimes it's the question you're asking ends up being not the right question or things like that type of problems.
I don't understand how it can swallow light.
No, I mean, but it's basically like you're writing like, how do I say it? So like you have this metric is telling you like if I have a coordinate system for my space time and I have then a notion of like the distance between points on it. And like a nice coordinate system is often some notion of like a spherical coordinate system where, okay, like very far away, I have this like, directions in the night sky, and it's like a time direction in this case. And then in the coordinate system, there's a solution to this differential equation that Einstein gives you where you don't have any matter sourcing outside. And it ends up being a black hole solution where there ends up being a horizon. And you can just kind of play around with like, how does like the energy like redshift or whatever, things like that. It's a fun, it's very much just a math problem. You know what I mean? Like you're playing with a given solution. So it's like kind of like, it's harder because it's nonlinear, but like when you're doing like multiple moment expansions in E&M or like just like literally like if you give me some charged object, put it here, what's the electric field far away? Mm-hmm. Or I don't know if they've any fun. I think if I try to make an analogy that you could probably help figure out one with some telecom, like reverse engineering from all these different radio signals, what's happening. I don't know, but yeah.
What do they look like from, I mean, how do I say this?
Yeah.
If we were to do like a 360 model of a black hole.
I mean, I think the best thing is like I forget which, I'm gonna get the name of the movie wrong, but like Kip Thorne was a scientific advisor to this whatever. Oh man, I wish I had a better recall of like names of cool movies. Interstellar, maybe. I hope I'm not wrong on that. Where they actually ran a like simulation for what it looks like. I think that you have pretty good like images from either like that movie or.
I've seen the images.
Yeah. You've seen the light coming out of it, right? So that's why it's like
they look like. So if my fist here is my hand is the black hole, what does it look like from this angle?
Yeah, but you
is
see
it flat or does it look the same?
Oh no, it should be round. It should basically. I mean, there's
it's actually a hole that's you can access from any direction.
And so ironically, I definitely have like colleagues who play with these type of like ray simulations more than me. So the way when I see a black hole, I see like a metric, I see an equation written down and I like, this blows up here. That's not, but the point is that when you're seeing those simulations, I think a lot of it is you're seeing like, imagine you had some stars behind it and then how that light from the star is coming to you. And so like, maybe it looks funny because literally like, you're not necessarily seeing the fact that you're also seeing nothing came from it kind of, but you're also seeing some like funny lensing of like the stars behind like their light kind of going on geodesics around and coming to you. So some of the artifacts are that, which I guess is what it looks like. But the thing, I think you literally know what it looks like. And I don't think it would be that hard to like do some sort of simulation of like you're following a geodesic down and then there's a bunch of
I want to look at it from
particles with you with some light. It's just like a question of like how do you want to set up? It's like
from the back.
Yeah. So roughly has so a normal like non-rotating black hole would have like spherical symmetry. A lot of black holes are actually kind of rapidly spinning, so there is some like asymmetry. You can see like it'll depend on like where you are compared to this axis of rotation, but there's not like a front and back thing. It's more like an axis of rotation difference.
So what is the shape?
It looks like those like
Is it a
roughly
ball?
It's like it looks like when those images of the black hole have this kind of funny like distorted ball looking thing. But again,
Three-dimensional though. What does it look
no,
like?
that's so you're
Sphere.
seeing it. It's like if a surface of revolution around it, I think is the rough picture. Like the things are symmetric roughly around that. But again, assuming that like, and I think there's no reason to assume otherwise that like the light sources around it are kind of evenly spaced because this thing is rotating. So there's a rotational symmetry, and you should view it that way.
Do you think it could swallow a planet?
I mean, I have no reason to think not. I guess the question is like, sorry. So like, I have to take a step back and make sure I'm not like saying something that much for the experts would be concerned. But like, to the extent of what do you want to consider a planet? Like, I think that like, just because something is like gravitating and it was always there, like, our planet, we're orbiting something that if I just wasn't moving like this way, I'd be falling in. So like, so like it's not just because it's there doesn't mean it's like swallowing a planet, but sure, something could fall into it. And I guess if you wanted to say like the only thing I'm worried about is to whatever extent the thing was the original like thing the planet was rotating around that you called it a planet for that reason, But yeah, it's like it's a hole where you don't see the light coming out, but I don't think there's anything stopping it. I don't know if I've ever like looked or tried to find a nice numerical simulation of just imagine that I have me and a bunch of other particles with some light sources are together falling across the horizon, what it looks like. I think it doesn't look that special, and the thing that looks special is you're outside and you're seeing all the light around it kind of being warped by it.
Okay.
Yeah. I'm sure it would look kind of fun. Like, I don't know why they don't. Like, you could do it. I mean, there's nothing, like, that's just a differential equation you're trying to solve. It's like, no. Yeah.
All right.
Ray tracing.
All right. Yeah. Let's move into celestial holographs.
Yeah.
Celestial
holograms. Yes.
What is that?
So it's a
this is what you're doing exercise. Right now, right?
Yeah, I know. So yeah, I think some British Twister people have some fun like sense of humor of how they name things as far as like celestial sphere and the heavenly equations. I think there's fun things. But so celestial sphere literally is, night sky, stars. If you're like Millennium Falcon or whatever and you're accelerating, you might imagine that like you'll see the distribution of the stars in the night sky move around a bit. So like they're going to dilate. And so that's somehow seeing that there's like the boost symmetry of the space-time is a dilatation of this sphere.
This episode is sponsored by BetterHelp. Summer can be a great season, but it can also get overwhelming fast. Travel picks up, schedules change, weekends fill up, and before you know it, you're trying to keep everybody else happy while you're running on empty. Sound familiar? And I think a lot of people feel that pressure. You're supposed to be enjoying the season, but sometimes you're just trying to get through it. Therapy can help you understand what you actually need, where your boundaries need to be, and how to build a summer that feels better instead of just busier. BetterHelp is the world's largest online therapy platform with over 30,000 therapists, and they've served over 6 million people globally. Their therapists are fully licensed in the U.S., and BetterHelp starts with a short questionnaire to help match you with someone based on your needs and preferences. And if you're not happy with your match, you can switch to a different therapist at any time. You don't have to say yes to everything this summer. Find support and therapy. Sign up and get 10% off at betterhelp.com/SRS. That's betterhelp.com/SRS.
So what we're doing is trying to do just like map all of the observables that we want to have to this night sky times a null direction that's complicated to do with, so we just project it back down to the night sky. And the reason why we do it is, again, because we're just copying and pasting and then generalizing things that have worked before. So both someone like Hawking thinking about putting quantum field theory on a black hole, or someone who's like a string theorist who's saying there's like 10 dimensions or 11 dimensions, and I'm gonna like have all these all this extra field content that I then have to like have this extra dimension like wrapped up and be tiny and never see it fine. But both of those types of frameworks end up leading to this cute notion that somehow the easiest way to get around describing a quantum gravity system is to find an equivalent non-gravitational system that it's dual to. And so from the Hawking point of view, it's like there's a sense in which this black hole behaves like a thermal system where the entropy is this area law. And so, okay, there's this fun kind of almost information theoretic vibe to like how like gravitational solutions. Then from the string theory side, there's this kind of more complicated, like some theory on brains back reacting, where you have a more precise actual equivalence between, I know some very esoteric, like bulk strings on like some gravitational space-time. That's the wrong cosmological constant, wrong number of dimensions, yada, yada. But it's equivalent to another gauge theory that I know. And so a lot of people in my field love like those precise dualities, because then they have power on both sides. Maybe some things are easy to compute as a geometric object and other things are easier to compute on the other side. And so you can study like different, like strongly coupled limits by having this other approximation or other approximation that's valid. But both of these things to me are just saying, okay, you have, again, this effort to like, there's a reason to think that maybe one tenet of quantum gravity is this holographic nature. And then we're trying to apply it to these asymptotically flat spacetimes, which are, again, the kind of the flat earther analog of cosmology. But like, maybe I should stop saying that. Yeah.
Sounds like I have the core question here. Is everything we see in 3D space, 4D space-time actually projected from a 2D surface like a hologram?
See, that's the thing is I would say in some sense, yeah, by definition, but like how physical is it? Like, I think what I'm saying is that, and maybe this is a problem with someone who ends up spending too much time just in equations and not in like real world. Like if you can describe things the same way, you might as well use whatever definition is useful for some things, right? So I think I don't always take it too literally in the sense of like we are in this celestial sphere. It's more like, can I convert everything to variables on that celestial sphere? And does that help me organize some scattering computations in a way that like would just get computationally complicated to compute all these Feynman diagrams or something like that? That's the kind of goal. Like I think I view it as like it's another math framework that ideally, if we do it right, is equivalent. And then don't overinterpret like the physicality of that per se, but it probably is my own problem for not trying to take things more literally because we are studying physics after all. Yeah.
So I don't I'm trying to understand this. So are you trying to prove that everything we see is a hologram?
I think that I'm trying to build a version of a holographic framework that works for spacetimes that are not anti-de Sitter. So like spacetimes that are more relevant for like scattering. How does gravity want to be described, quantum gravity want to be described by a boundary system? So we're trying to build that out. And at the same time, if it were true, then the two things are equivalent, not that like, so like if A equals B, I'm not saying everything is B. I'm saying everything that is A is B, right? So I'm more like saying there's equivalent set of things. Like you could imagine a world where maybe I don't know, try to project everything down to the Earth and then talk about some rules for how those things interact. And it was more convenient to talk about the extra dimension. I don't know, like, but like you're not trying to lose content that way. Certainly, it's not supposed to lose anything. But it is neat to think, okay, like if everything is described in terms of boundary observables, then it does kind of call into question which questions are well defined in the bulk, for example. I think that's it.
So celestial holography is your way to prove this and use it to unite Einstein's theory of general relativity with quantum mechanics. The two foundational theories currently contradict each other.
So, but again, there's a lot of people where you could probably motivate their research as inspired by. And the question is like, I'll go and so it's funny, these things go in and out of fashion. Like I think I've heard from some like postdocs now that it's not cool anymore on your grant applications to be talking about like quantum gravity. But I still think that's why we go into, like we don't go into the field because, okay, so there's two maybe reasons why people go into the field. I think some people genuinely like paradoxes. And it always bothered me because it's just like any paradox where someone actually had the answer in the end, like you just defined it wrong. So I went into physics because I liked that I didn't have to learn as much. I mean, the sense of I don't have to have an excellent working memory nominally if the laws of physics are simpler to then figure out what the rules are simpler than the solutions. So I like physics for that. That doesn't necessarily bode well when you have a very complicated corpus of things and so on. I think the reason why we study something like quantum gravity is, again, because we have this bias or we think that, you know, whatever the laws of nature are, there's a fundamental set that then lead to all these different regimes that you're studying. And if you didn't have that bias, maybe you shouldn't be doing that job. But if you have that bias, then the thing that you should be doing is trying to, again, merge various rules into a single set of rules. And so I guess the big outstanding one is this like short distance physics and long distance physics, because at some point then we know that there's quantum mechanics and we know that the GR is important. So like there's some sense in which the actual observations guide you to this still open kind of problem of what theoretical frameworks can consistently limit to both. I mean, to the extent that like, why should the rules of like tennis versus hockey have to be united, right? I think that like, it's kind of cool that we think that the laws of nature are like, there's something fundamental about it. Or there's something highly compressible like about that description. And I think that's a fun hypothesis even rather than just a belief to try to test it. And you can kind of automate what you do as researchers in the future. But yeah.
So are you,
Yeah.
are you saying that everything in space is potentially projected from a 2D surface?
That would be, sorry,
Or
I think what I'm saying is
everything
if,
here too?
so like space time. So for me, it's like, it depends on, so sometimes you use the word space to mean space time, but it's 3 + 1 dimensions is our world. And then the boundary is 1 dimension lower typically. And the celestial sphere is 2 dimensions lower because the boundary for these flat space times is null in a way where like basically no other direction can talk to each other. So again, the point would be, can we find an equivalent description or almost like we've seen it work in the past. How do we apply it to this regime? And then how do we learn something by seeing how we can't import it? So again, physicists are constantly using mathematical frameworks that they already have and then trying to tweak, like apply them to something different and then realize something goes wrong and then try to like learn about that framework by seeing how to modify it to make it work. And so like in some sense, answer is yes. But at the same time, you want to try to see if I built a framework like that, would it tell me anything different about the structure at scales I can't see? But like ideally, like it's a bad framework if it can't like in principle encompass the things that we do have the intuition for in the bulk or in our world. Yeah.
This is way over my head.
But it's way over everybody's. I mean, that's the thing is like, like I think that so especially when this hype happened when I was younger, I was very much like, I'm going to go and read a bunch of textbooks because I want to be able to like answer good questions or like, know how to tell the flat earthers why they're wrong or like you're representing science somehow in a funny way. And it's just like, like you need a much better working memory for that. Or I don't know. I think the thing is that, you don't need it. Like in our job, you can do this kind of like you're diving in, you're doing a computation. And then sometimes you lose sight of the breadth of it. But I also think that now it's a fun time where you can kind of take a step back and see if there are things where, the resource limitations or just the way that physics is done doesn't need to be that way because like now, one researcher doesn't need to hire a whole team of like data scientists to treat the corpus as a data set and do something with it. Like there's a lot of power to having like fun AI tools and like you get to just basically play around with doing things that you never would want to do normally as a good researcher because that wouldn't help you with your career. Yeah.
Okay, I'm going to ask you some very, very, very basic questions to try to understand this.
We'll see.
Are you saying that a planet could be a hologram?
Yeah, but in a weird lawyer sense, not like in the way,
A star?
No, I think what we're saying is like all these objects that you're thinking you're in the bulk and like there would be some state on the boundary theory that's equivalent to it in these types of holographic setups. I don't want to say that I understand flat space holography to the level where like I'm confident in that, but in ADS-CFT context, their dictionaries are like, yep, like this massive state is this other operator in the CFT type of.
Potentially, everything we see in space could be a hologram. Or are you saying the fabric of space?
Everything. So like basically the whole point is that there's 2 equivalent theories. So the thing that you have in the bulk, you want to have in the boundary theory. Can you formulate a theory that lives 1 dimension lower that isn't just so like, is there a natural sense in which you want to live 1 dimensional lower? And for example, one kind of intuitive thing of why it might be nice is that if I have a global symmetry, so I have something that's not related to these long distance interactions, then typically I need to go and like kind of measure the charges of the objects throughout the like constant time slice that I'm in. But we're saying this is Gauss law story that I can measure the electric charge in a configuration by just having some probe of the electric field like at infinity. And so in ADS-CFT, there's a sense in which this boundary theory is evolving in time and you want to find the dynamics of the boundary theory. So like there's a dynamics of the boundary conditions of the bulk theory that end up like I guess, telling you is an equivalent presentation of the bulk theory. So I think the fact that it is holographic is deeper and probably if it were true, has deeper implications for like the right physical quantities to be talking about in the bulk. But again, and so I think that's a sense in which, sure, if I felt more confident that the state of the dictionary were where I really had a good intuition for that thing, then I could try to pull back and say, let me, like the fact that it's described as this boundary theory, what does that mean for what's a good thing to talk about in the bulk? But I don't think it's formed enough for me to have that type of assertion or make that type of enthusiastic claim given the danger of like how it's interpreted. Yeah.
What are you visualizing in your head as you describe this?
I am visualizing as a Penrose diagram with a sphere and just some like light shades, I guess. Probably that and or yeah, some equations. So I'm basically just a bunch of Penrose diagrams, right? The slides and the talks I would give.
I mean, you're visual. I can see it. I think you're visualizing.
Yeah, I do. I know, but that's not necessarily very helpful, right? So like that's a problem with like when you're a grad student, they often say like shut up and compute. And I used to take it as like a personal offense, like I can think too. No, but the point is you're trying to be trained out of using your physical intuition, for the things that you're doing. Because again, like, you can't see 10 dimensions. You can not even barely see like, 4 if it weren't 3 plus 1. So like what can you physically do in this world where we clearly are interacting with certain energy scales, 3 plus 1 dimensions at a time? How do you get out of that? And then you build this intuition by computing things, I guess. So then your intuitions are roughly a bunch of computations or a bunch of lower dimensional projections of things if you happen to have someone who can make nice figures. But yeah.
What do you believe happens when we die?
Oh, God, I don't know. But yeah, I mean, my mom's very Catholic. I don't know. I think the thing is like, that's a funny thing. Physics probably tells you like, gives you some sense of which questions you want to ask or not. And I guess the right answer from a physics point of view is, I don't know. Right. Do
you think about it?
I luckily like I'm happier, so I guess I don't. But no, I think that that is the weirdest thing is often I can fight with people I think are friends in a fun way of like how to interpret the observer. So like, yeah, like I definitely think that if you, and I mean, to the extent where we don't agree, like, I don't know actually who's right on it. If like, how much is the fact that like I am a me, like somehow I feel like physics can still describe, or at least it doesn't obviously like tell me I couldn't have, some objects that end up having these complicated like neural nets in them that interact with the environment and it changes the set of it. And so it feels like they're making decisions based on that. But that's a different question than like, I feel I'm me and I feel interact with the world. So I think if I wanted to say that physics like covers everything, then I probably do want to have the observer be part of the system. But I definitely have friends who are definitely not religious or anything like that and still kind of call that observer thing into question. And I just don't know because again, I guess I don't like open systems. I don't know, like from the point of view of what are we doing as a theory. But yeah, there's fun questions about that are related to this in the sense of like who am I versus like, and is it the same thing as. Yeah, I think how active the observer is or something like that. I still probably am biased to not including that, but maybe that's dumb. That could easily be dumb. Yeah.
Do you and your mom talk about this? You said
no, because like, I'm not good at. Neither of us are good at debating. No. She definitely sees what I do as a variant of religion, and I'm like, nah. but I also, it's very easy because I think we're so close to like end up going too far with questioning the stuff. She came from Cuba when she was a kid, and they weren't allowed to be religious there, and so I think that, it means a lot more to her. Partially because of that, but also, I mean, it gives her like a very sense of like guidance in the family life and things like that. It means so much to her, right? And so, yeah.
But you don't.
No, that's the thing is, I personally view like a tension with the like dogmatic aspects of like that the answer. Like, I mean, what I love about physics is that there is a sense in which like even though. First of all, like the level at which I actually understand these things is so silly and whatever. But there's a sense about science that if it's done right and honestly, like you can have these revelations, like you can learn something about nature. And I think that whether you're religious or not, everybody appreciates like nature. And so we're trying to find the rules. And if anything, that seems pretty close to the spirit of like the part of religion that gives you the answers or some like sense of like, this is the way things are. Right. I mean, like you're trying to find an origin story, right? So like that kind of origin story aspect of it, I think that science is after, but I think that I like the fact that we are supposed to admit when we don't know things. Sometimes that doesn't always, it definitely plays out in a weird way, because a lot of people think they're experts and then like talk down to people who don't. And so it's very dogmatic in practice, but it's not supposed to be that. And I love that about it. And that's the thing that turns me a little bit off of religion sometimes. It's just like, like can you question things or whatnot? But I think this notion of not knowing is clearly fits into this notion. Like if you thought there is something creating everything, maybe that's more of a reason that we're special, or more of a reason that the rules have to be simpler because. But like I tried to be more agnostic, and I also am against the kind of dogmatization side of it a little bit. But I'm happy to try to debate or change my mind a little. Like I seriously, my mom, and it's just like, yeah, why aren't there women priests?
Right on, right on. So what does it mean what does it mean with the hologram stuff if it's projected from a 2D?
So again, I think the thing that it will mean is once I understand it better, that there's some types of things you do or don't want to talk about within the bulk space time. But I do think like I care about physics, not because, I mean, you land on this one little corner of it that you get to play with. And it's somehow the best bet for you because it uses the things that you know. But like, it always frustrated me, like how hard it would be to jump between different fields. Because you, like, imagine if you have no experiment culling different parts of the research canon, it's just going to get harder and harder when there's more alternate attempts to something. And I don't know enough about loop quantum gravity to tell them why they're wrong. And I'm just basically vouching because I trust like one other person's opinion who might have looked at it. And so this is funny thing where like this just the kind of the output of other people that are also really smart is hard to internalize and compress. So I like this notion of being able to think about taking a step back and saying like, we value physics for this type of reason of like finding these deep questions, trying to like see that nature seems to be like have this highly compressed description. How would you go about finding it? Like, can we view ourselves as instead of like individual people who maybe do a great thing and they could call themselves an Einstein or whatever, that instead of it, like we're responsible for this legacy. We're custodians of this canon. Are there tools now that we have that we can be like help curate and like condense it more systematically? And I think that that's an exciting time for me because I love that notion of, don't just stay in my little corner. Like, how would I get out of that corner, first of all, personally, but then how is it also like you view that venture as something super valuable, I think, and closer to these kinds of like deeper questions. But I don't think I think about the deep questions enough because I'm in the computations, because that's the thing where the intuition comes from, and then you just get stuck philosophizing if you're not, if you're too far away from it. Yeah.
Man, how would this change the Big Bang?
Oh, I think that it's
Bang theory.
I think the Big Bang Theory thing would probably tell me that something about my framework has to be tweaked or something like that. I view it more because again, like, like a cosmological origin side of thing is very much like not part of the thing I'm setting up. So the first side of it, if I need to include de Sitter, the stuff that I'm studying is more of like a stepping stone to understanding how to generalize holography. And then the second part of it is again, like initial conditions or things like that. We're not necessarily always, sometimes we're thinking about the equations and not like the solutions of the equations and the particular ones that are relevant to the real world. So I would say that it's not going to do for the Big Bang. It's more what will the Big Bang tell me I need to like specify once I understand better if my framework encompasses that or not. Yeah.
Do you believe we can time travel?
Forward at different rates.
How so?
Oh, I mean, sorry. I think what I'm saying is like, I'm just making the joke that we're all going forward in time. But to the extent that even they have this in this Interstellar movie, if I got the name right, like this kind of twin paradox of like your clock is affected by gravity. And so you can, go around and come back and have aged differently than your twin, but you're only still going forward and whatnot. No, it's fun because we don't like, and that's a kind of fun thing too, is like, there's still cool stuff like, but the no-goes are there. And you never really get to play with all the fun things. I think like it's always this funny thing of like, sure, you can do this thing, but the caveat is it's not physical or whatever. Like, right. So this thing about like, you can age differently, but you can't like go back in time type of thing. And it's also because it would be sometimes things are built into assumptions. Like it would cause a lot of other problems if you can go back and like a closed time, like curve, you're influencing your own future. Like, yeah, I just wish that, I think the thing is that like in order to make progress in the field, you have to be so in the nitty gritty that you don't get to like have fun, like bullshitting around with like the things that people think physicists do. But perimeter's pretty close. We have a pretty fun, we have people who do like quantum foundations and like a wide variety of just theoretical physics, where sometimes that it feels a little bit more like maybe what the stereotype of a physicist at a chalkboard debating like existential things is.
Let's talk about quantum mechanics versus Einstein, the
Yes.
fight at the edge of reality.
Yes.
Where do we start?
We're framing it as a fight, man. No, I see. More like, again, this is the type of thing of why do we believe that the laws have to be coming from the same thing, right? I think that that's a pretty bold and fun assumption. And if you can imagine that if somebody thought that like at every different energy scale, just there's some new things, because that's the way it is, that you couldn't predict, that's a very different vibe than thinking that like there's a mathematical consistency or some kind of underlying principles that will carve out a space of theories that still can be consistent with observations. So what I view it as is, again, as a Hep theorist, we're making this bet about the structure of these like laws of nature that probably has some consequences that you wouldn't be able to see when you're just in the nitty gritty of it. And that excites me a lot. Thinking of like, okay, if I could zoom out and see the structure of the corpus and like which theories are actually consistent with each other, wouldn't that be fun? And so I think I like that because that feels closer to the kinds of things that excited me about physics as a kid. Now, it's still further away from a lot of like, there's some companies now that are trying to do like AI for physics with a thing of like, we're gonna like, like robots are gonna come out of the physics thing. It's like, it's probably not physics the way I define it when that's the case, but there is cool, like you can unlock cool things when like you're changing the way you're doing things. And I think that forget for this quantum gravity thing. It's about trying to condense this corpus. You're trying to like find a single description that can limit to two different things. And right now we really have only a limited number of suggestions, like roughly string theory as a framework. Can you try to find other ones? You probably never would if you're just sociologically in a field where everything you're learning is in the context of like within string theory. It'd probably be some variant of it at any point, just almost by accident. So I think it's kind of fun to do a little bit of a meta layer and think about like, what are we actually after as a field, and be clear about those goals. Yeah.
What is the Perimeter Institute?
Oh, I love it. So Perimeter is founded by Mike Lazaridis. He's one of the co-founders of BlackBerry, and he's one of these like, tech entrepreneur physics fans. So like, I mean, obviously like he kind of ahead of his time with the smartphone type of thing, was an engineer, awesome engineer, and then like liked physics, then put a lot of money into a physics institute. I'm not sure, you have to be a fun kind of, I don't know if it's a brilliant idea or a silly idea, but it's definitely good for the physicists. So what I love about it is that it's like a research institution that's like a private-public partnership. So like his money is highly leveraged and like the Canadian government supports it just for theoretical physics. And so it's neat because you can imagine, if you cared about the product, you care about research, having something where the whole institution is dedicated to that is a very different vibe than, again, like a university where you are like, you're pooling like your 8 like auditoriums or your dorms or things like that. And it's all these different research directions that are together sharing some resources, and you're kind of like cross-sectioning the field. And then it's a reputation of that place that draws some talent in or not. I think there is value to this kind of cross-sectioning research by the product or like by the discipline. And Perimeter is an instantiation of that, but like with the downside of it being in just one place in Waterloo, Ontario, where his company was and things like that. So I understand he's supporting
you went there instead of taking a $1.1 million.
Yeah, but these packages are for like research funding and things like that. So and research is, I guess, I know people are expensive, so that's where these things scale and sound like fancy numbers. But I mean, but at Brown it would be very much like a Ivy League professor. Sounds cool. You're teaching a lot, but again, you're just kind of at a university that has one reputation compared to other reputations. I don't know, like that type of vibe of like within the U.S. system, Harvard will get more money than Brown would. And then versus at least at Perimeter, it's kind of a startup vibe, or at least in principle could be. And then you try to make it that, which is fun, but we'll see if they let. Yeah.
So what are you doing at the Perimeter Institute?
Yeah. So I do my research there. So I do my celestial holography research, and it's basically like your faculty. You don't have to teach. You mentor mostly like master students up. And then but they're more forgiving, or like the kind of institutional things that you're helping with. And so normally it's like, instead of being on committees that are just like in a big department at a university, we don't care, you're closer to being able to help guide the institute sometimes. And so it's kind of fun because you get to think, okay, like we're this institute that has like outreach teams, that has like teaching teams separate, like that really value each of those facets of physics. How can you help with that as the researcher? And I love that type of question. I love thinking about like how we can position ourselves to collaborate more with like tech companies for like AI for physics or things like that. And I don't think that question is as meaningful if you're at another university, because that university doesn't care about theoretical physics. They can change their mind on who they hire later, and they can meander over time. And sure, there's probably awesome like CS departments at places, but like like you can really focus on a thing when it's your whole mission. And I love that about AI.
Do you think AI is gonna? What do you think about AI?
I'm excited. I'm sorry. Like I used to be more so. Like again, I think my opinion. At least I'm happy that my opinion can change. I feel like that's a positive thing. But like I was definitely more like jaded by people oversell things, and like what if they oversell things too much to the extent where then it hurts the like it's not like there is value to expertise that I think that sometimes people overcorrect on things when they don't trust like science and stuff like that, right? So like how do you engage with like hard conversations of like where is this field going or things like that without throwing the baby out with the bathwater or like making it hard to like collaborate? So I used to be more like, oh no, they're gonna say they're gonna do all these things. I know that my heroes kind of liked physics, so is it gonna be like the guys with the funding get access to all the data, start making some claims of theories, and then like don't know enough to be able to tell them why they're wrong, yada yada. The route that ended up happening instead is more like, oh, we're gonna like take the top people in the field, like not like the Harvard professors, not me, and just work with them and collaborate with them first to then, it's a reputation thing. But it's fine. It makes sense. It's a business move. It makes sense. But it's a funny thing where we're more a part of it than I might have thought. I thought it would be like, we're going to get overwhelmed with a bunch of crackpot papers by physics enthusiasts. And it's less that and more, more this funny thing where it's just, we're all in the labs for a little bit or not. But like, how do we really do this right, instead of it being like, okay, so say one company wants to show that they're doing some research, they can like work with a few top researchers, and then the top researchers can say it's interesting, but like we want to do cooler shit than we could have done before. And how do you like I think that it's funny. It's like, you think it wouldn't be that hard to try to just get a bunch of string theorists to like, let's do what they did for math, write down a bunch of like well enough defined questions and dare someone to like try to automate it. And even we could have more fun. We could say like, okay, Sam Altman, you're saying ChatGPT 8 is going to solve quantum gravity. Let's put some parameters on that and make a bet. And if you like do it by that time frame, whoever did it gets that prize pool. If not, give that money to fund the researchers. I don't know. Like it'd be I think there's a fun way to do like X Prize with these deadlines, because the thing that scares me the most is there's a lot of confidence. And once you start playing with the coding side of the products, I can see the confidence in that. But like, to what extent, like a company can always pivot, and you can be like, that claim is bullshit, but they still will find something else that works, and that's great for them. So you don't want to short the company or anything like that. Like, how do you call them out a little bit when they're overzealous, if that overzealousness can hurt you? On the flip side, though, I found that like, the agentic coding, vibe coding capabilities are just amazing, because you can have all these little daydreams of how you want to interact with the physics paper. And like before, when I was a perimeter, they were supportive of me like trying to use some of my like grant money or startup money to like hire some interns from like local universities to code something up. But like, I was a shitty coder, so I'm not good at managing people at tasks that I don't know what I'm asking them to do. And then like I was so bad I couldn't even like basically host this thing locally to show people what it was. And like within a few weeks, like I could basically redev the same thing with Claude Code, which is like amazing. So like I kind of see that sometimes that hype or that push can drive a product to a level where like now I don't need to hire a dev team. As a physicist, I can start to play around with things that I couldn't have done if I didn't know how to code myself. So there's skill sets that are open to me because it's been kind of democratized. So I'm grateful to that. And that's a bit in tension with my kind of about like, we're going to solve physics, and then it might like, take the funny way. So like, I think, like, well, at least like, thank you.
What are you going to do if they solve physics?
No, but this thing is, that's the question, is like, what does it mean to solve physics? I want to make sure we have the same definition of that. Because I do think that it would be hard to imagine actually solving physics to the extent where like, until you build an experiment, you can't rule out space of theories. I think the coolest thing is to try to think, okay, there's a lot of things in our field that you would never do because, again, resource limitations. So when you have a couple of thousand people who awesome, smart people, like definitely, like I feel dumb all the time. They're awesome people, and they do their thing. And, like you self-select accidentally for the type of people who just love mathematics, to the extent where then like you can accidentally be ostracized if you are too ambitious within that framework, because again, who are you? Right. And then also just it doesn't help you get the job. So like there's some things where it's like almost like an emergent phenomena of things that people try to say are institutional problems. It's like it's really not anybody being a bad actor. It's just like you get kind of stuck in the way that things are done because people obviously like what they do, and the people who like it stay in it, and the people who don't are expelled, right? So imagine like you have something where it's like if you feel comfortable with things operating this way, then you stay, and otherwise you leave and you resent the field. Then like that's a bad thing sometimes. But now I think, there's enough. Like, so you have this thing where basically before a lot of people would go and like, you wouldn't value doing brute force, straightforward things that are just like scanning over spaces of stuff because that won't lead to a breakthrough, or like, is it one individual, you can't do it. But if you can automate that, like, sure, like there's a lot of value to types of questions that nobody would have cared about, but that then makes it a problem with benchmarking. So like, for example, in other fields where there's more of an engineering challenge or like a very specific goal in mind, you can say, this goal is valuable. And then, protein folding or whatnot, they can do it. Or even in math, there's more like, I guess, like tests for kids. The community seems a bit more organized, a lot more like IMO problems, like different benchmarks of like, how good is it at this thing? In our field, I think that we kind of don't like often to say whose research is more valuable than others. We definitely feel like there's totally a vibe of like judging things. But like that kind of ethos lends itself to not wanting to just straight up say, this is a valuable thing that you should do, because if it was so straightforward to do it, it wouldn't be an interesting question. And it's like, that's dumb, because like anything that's worth doing, like you'd think it'd be worth telling someone else to do, right? And so I think that we just got to get over that in our heads a bit and realize like that just because in the past you could only give faculty lines to people who like happen to have a great idea, that there isn't value, because the whole enterprise it's physics, it's not math. It's like there's some cohesive structure to this thing. Like, how do we optimize for that? And I think it's fun because I think tech can disrupt that a little bit in a way that isn't going to necessarily, hopefully not in a way where it's like completely just erasing it. I think that there's a lot of value to that expertise, and like, how do we harness that to do something really cool with it, instead of it being this thing where someone who's not an expert just thinks it looks like it's doing the right thing,
What is something that you want to dive into that you haven't yet?
Yeah. So, I mean, for me, grass is always greener on the other side, in the sense of like, you feel siloed, and like, it's not like no one's siloing you but yourself in some sense. Because like, I guess for me, the one thing that I wish it was like, well, it would be easier for me if it wasn't, is like, I really like extrinsic motivation sometimes too much. So like when I'm computing, I can be happy, but I like if other people care about what I'm computing, and sometimes they don't, because they each care about their own thing. And like, I don't think you're a better person or not for having like less extrinsic motivation, but it's hard to navigate, like, if every person just cares about their own thing and you're like, how do I do something this person cares about? I want to jump into their thing. But then like they see it as a waste of their time to necessarily like, transfer that knowledge or something, because they have their own grad students, they have to do the research. So it's hard to move around in a funny way, just because everybody's doing their own little math. But so I just wish that I could better parse other people's papers, understand like how their notation, their ideas fit into the things that I've already built in my mind. And so like the type of thing that I'm excited about more so is just, can I take Inspire, have this database of all the different papers in the field, and try to like use large language models or whatnot, just for fun, to see like how much I can try to parse like the different concepts that are appearing in these papers. And I think it's a fun game to be like, okay, when I'm asked to explain something publicly, why am I so shit at it? I think I've spent a lot of years, instead of getting better at public speaking, thinking like, why the hell am I so bad at it? And I think there's these trade-offs between, we are selected for, or at least in our job, it's better if you are not sacrificing accuracy. And so anytime you're making an analogy, there's so many caveats. The caveats get in the way of the intuition going through. And then sometimes you don't even think that way. So it's just like, can I try to like see the structure of the thing I'm studying a little bit better by like playing around with it within the scope of things that I know? So I'm like that. So I'm super excited just for the fact that like I can experiment with that all I want to, because before I might need to like be better at coding in Python or like understanding the Inspire API keys, and that's API calls. And then that's like automatic now. So you get to basically just have fun, and I like that a lot. And so for me, I just want to basically understand better, like what is the information content of what I work on, right? Like in the human sense, not in the ADS safety sense.
Right on.
Yeah.
Let's talk about the physics race between the U.S. and China.
Yeah.
Who's winning?
I mean, I think the U.S. is still like. I mean, sorry, but no, obviously, sorry. I think this is like. And I think this is something where I'm happy to hear your side of it too a bit more, because I know like everybody who has any sort of military background has a different view or conception of China than like, probably because physics is so useless. So this type of physics that I do is seen as that it's nice because everybody can be a part of it. So we love this notion that like doesn't matter what country you're from, you're contributing to like this corpus. And to be fair, everything that we're doing, we're publishing on archive so it's not like there's IP involved and like various IP policies can affect things. So like I like the fact that there's some little slice of research that's so far away from replication that like everybody can be a part of it, and it's not like what country you're in. And so when I see things like about like China funding an experiment, it's like, someone top down could just say, we're going to fund it. Hey, it's an experiment. And honestly, maybe it's a good thing if they're spending money on trying to be better at like research for just the type of research that's just for the clout and not for like the military tech or something like that. I can like let them build colliders, right? But I do think that the pipeline of transferable technology is much slower than just actually building a technology, right? So I mean, my attitude is I could see that there is, and this is the type of thing too. I think that very strong like top-down governance can do, and also different relaxations of like IP laws. Like there's a power to that you can see kind of Europe maybe over-regulating things compared to like USAI, right? So I like to think that as we are right now, and I still think it's more feasible to say that like the research that I do is so much less about the practical applications and the technology for like these space specs like detectors. I still think that the European Space Agency one, LISA, or whatever the name is going to be, that the US is a part of, will outperform this particular one I think that you were referring to, Tianjin or something. But I think it's great that like if they cared about it, they would fund it versus like you have a hard time sometimes convincing the American taxpayer that this is worth funding, so. So
you think we're ahead?
We are ahead, yeah. But I think that like, again, it's like, what do you want to be ahead on? Like, isn't it great that like they spend their money on the things that we don't value doing eventually, type of thing? If there's a reason why we don't value doing it, maybe it's great that they're doing it.
What are they doing that we're not doing?
Oh, I just think that they have like, sorry, for example, there's a lot of, I'm not sure if it's a good, sorry. So again, these could be like, different people have different, they're different. I mean, I don't know what level you want to consider it as a regime versus a person or like whatever. But like there's a like faculty member at Harvard or like it was there who has a lot of influence in China, which is great because then he can have research centers and he can hire people who wouldn't get jobs in America. So I think what I'm saying is that, in America, it's like, oh, we only want like the top person to like get a job or like these like elite things and we can get them from all over the world. And that's what we typically do. And then their route is like, there's a lot of awesome people that are never going to get a job in the US system. We can hire them there. And it sometimes works, but also right now it's still very isolating. So like the US would choose not to do that. Like we don't want to just hire a bunch of more faculty because like, but then once we've made that choice, they're optimizing, given that constraint, what can they do that's valuable? And I think that then like there's a reason why we made our choice, right? And that still has an effect of like everybody that I know. Like it's really hard in like India and China, I think, to like break out of those systems unless you happen to have an advisor or someone you knew who was in the US system, which is insane. Like, I mean, I feel bad for like the researchers. It's just like, it's so sociological in some sense. Like you can't just have a brilliant idea and like get to be a part of this like club in some sense, because again, it's not just it's almost more like you can't, if you don't speak the language or the right way, people don't think you know what you're talking about, or they don't understand you. And so like there's like pipelines that are very limited and very much go through the US and out, almost like go through like Princeton, Stanford, like Harvard, MIT and out, and that sucks. But that definitely just says that it's not like we're behind in that sense, right?
Are there any projects going on in China that you're excited about? I
mean, I'm less of an experimentalist type of person. I think a lot of, I'm excited for my phenomenological buddies if they think that they can get somebody to fund an experiment that the US wouldn't prioritize. I'm happy for them. I still think the things that I'm more excited about are still in Silicon Valley as far as I'm concerned, but that's my own bias. It's my own. Like,
what about the US? Are there any projects here that you're excited about?
I mean,
that you're not involved in?
I probably don't know all the cool projects that people are doing. I think that just the way that in the US, there's a lot more money that can go into innovation in a way that when the timescales for research in a company are so comparable to the ones in academia, sometimes that rubs me the wrong way. Like, I think that we're good at, there isn't a problem of putting money into innovation. So the question of like whose hands does it go in or how's it controlled? Like, but it's definitely the exciting things in the States. The States, you can move fast and break things in a way that I don't think you can in many other places. But probably in China, IP laws would be such that unless like, I mean, however we follow the law with like copyrighted material for training things, I imagine that they could have done that better, right? Because they don't care if they don't, maybe, I don't know the actual setup, but a system who doesn't care about IP can definitely, do cool things in some way.
What do you think about all these UFOs and UAP sightings and stuff?
I don't know. I wish they were real. It'd be cooler. But no, I don't think I believe in aliens, but I don't believe in like aliens that have contacted us. But
You believe in aliens?
oh, in general, I mean, there's statistically, I mean, so like I think there's a fun thing. So like either we're super, super special, or like sure, there probably are. Why wouldn't there be life somewhere else? Where are the initial conditions for where we are so special? I think that, people who study like I don't do this myself, but like there's the fact that you haven't interacted with them gives you some bounds on how common it can be, or like whether they need to be like in some environment where you can have water, or all those types of fun things. But sure, I think that like, I mean, the funny thing is there's called tension with religion stuff too. Like, I think there's no reason to think you're special unless there is a reason that you're special. And so modding out by, or maybe the prior being like, we're probably not special, would tell you, sure, there's something like an alien somewhere. Will you ever interact with it? You don't know. But I don't believe in like necessarily like, I definitely like, I wish that we had talked to aliens. It'd be freaking cool. Like, never mind.
So you think all these sightings are bullshit?
Oh, that's hard. I mean, but I don't want to say it like that's mean to say like that people don't believe what you see type of thing. But because I'm saying like, I wish if it weren't bullshit, wouldn't that be more fun? I think what I'm saying is like, I wish things were as cool. Like, all these conspiracy theories make it seem like there's much more structure and organization than there is. Like, I mean, just like, I mean, maybe
I'm with you.
Maybe
I'm
your
with
bias
you.
though is that you've seen the military when it works fucking well, and like that there is some cool shit that I wish I knew about.
I've
Like
never
I
seen any
see like
cool
the kind of like
UAPs in the military
Yeah.
that go into the water and have gravitic propulsion systems or whatever. I don't know. Yeah, I've never seen anything.
I don't know. I think
I've only seen stuff on the news.
yeah, but I think what I'm saying is like
But I don't believe the news.
I know that. Yeah, it's funny. I don't know how many people are actively. I think that we don't always give credit to the fact that people cannot realize their biases or that they are self-serving sometimes. Like, I mean, like, I don't know how much of it's like just Machiavellian or like emergent Machiavellianism or whatever it would be. Like, because
The one that really
Yeah.
gets me is the Nimitz.
oh, wait, sorry, say more. I don't know.
You don't know about the Nimitz?
I don't know. I guess not.
Multiple people saw it. It was some kind of a, what was it? It was like an egg-shaped, whatever,
Yeah.
projectile.
Yeah.
And it went in the water.
Yeah.
I don't believe it lost any speed. Came out of the water. Pilots saw it. People on the ship saw it.
Okay.
A lot of it was a collective.
That's super cool. I wish. I mean, I always
You
thought these things.
you haven't
are,
heard about this?
You're in a definitely different like set of like whatever like internet feeds.
We
than
definitely
I-
live in different
Yeah,
worlds.
which is no, but that's fine in the sense of like I know that I have biases coming from like the experience of like who I would have like kind of spent a lot of time around, but no, I mean I think I always thought maybe it's cool military projects. I don't know, like, and then like sometimes like optical illusions for like it being if it was physically impossible, but
That's what I wanted to ask you about.
Yeah.
Why? How could it be an optical illusion?
I mean, I don't know. I haven't seen the thing to know that answer, but I mean, like, first of all, it's going to be more fun now that you can AI generate stuff. Like, we're going to have like a real like fake news at scale accidentally or maliciously. I don't know, like that's scary. And then the other side, I don't understand the extent to which things are physically impossible for it to be just some like whatever drone or something you don't know. I know in this case, I'm not talking about this example of going in the water. It sounds weird, but I think what I'm saying is that. Yeah, I guess the one question is like when someone does believe it is that thing, they're so confident it's an alien and not like whatever. Why do they think the alien can do something that we can't do? Because if it's all the laws of physics, then probably it's the same capability. So then it's just a question of like how advanced is the U.S. military or other whatever, right? Or what are you actually seeing versus what you think you're seeing? Because you're again extrapolating based on like other things that you're used to looking at.
Could it be a hologram?
No, I'm not going to go there. That'd be fun. No, I don't get a little quote for that. No, I think again, I'm saying more in the literal sense of like you're probably misunderstanding what it's being seen if like there's a reason why it physically couldn't be some military tech. Right? Is what my prior I'd love to be wrong. Right?
Could we project a hologram?
I mean, I think what I'm saying, like, I mean, sorry, to the extent, I don't see any reason why you couldn't do a little, come save me. What's the quote from the, Princess Leia? I don't know. Like, that type of thing, which is a more literal version of the hologram, not the one that I would study. I don't know where laser shows are at nowadays or exactly what. But see, the thing is, I think I always take the more pragmatic attitude of, like, build cool shit. Like, don't ask what is actually true. Like, try to engineer a thing so that it is, if it's possible. But yeah, maybe it's less cool for the UFO type of thing. But, like, imagine the thing that would have to be true for that to be real. Do you believe it's true, or do you want it to be true? Or do you not want it to be true? Like, what's the conclusion that you draw if there's, like, really some, like, deep state type of thing that's hiding all these alien cool stuff? Like,
I think it's all bullshit.
Exactly. I do too. But
all of it.
Yeah. But, like, the person who then doesn't think it's bullshit has this probably in their mind, like, a more, like, powerful version of the US government having, like, some really cool, like, Men in Black tech, right? I don't know. That's kind of appealing or fun. Like, I think that we need to.
I mean, it's a fun thing to think about.
Yeah, lay off the conspiracies and make the cool stuff, like, that you can do real.
Like
you know what I mean? There's a lot of stuff that's, like, same isomorphism class of, like, that's fucking cool. Like, this, like, whatever, like, autonomous F-35 thing you're talking about. Like, there's some cool shit that we can do.
What did you just say?
Oh, like, no, that you, like, someone was going around and showing me the different things that you had. And I forget, one of your teammates was showing the, some, like, scaled down model of a military type of thing that a private company was doing. I don't know what, but no, I don't know. I think I wish that, it'd be fun if, like, people, like, if it wasn't just defense funding that got to do the cool shit. Like,
I'm with you. I'm with you on that. Well, Sabrina, we're wrapping up the interview.
Good.
What are you getting into next?
I think I'm getting into being a shitty vibe coder and just seeing, like, getting to have fun, like do my physics, and then on the side, kind of try to look at this, like, bigger scale picture of the corpus and see how far I can go with the little, like, do it yourself type of attitude until I need help, and then ask for help.
Love it.
Yeah.
Love it.
Yeah.
Well, Sabrina, this was fascinating.
Thanks.
Thank you.
Thank you so much.
No matter where you're watching the Shawn Ryan Show from, if you get anything out of this at all, anything, please like, comment, and subscribe. And most importantly, share this everywhere you possibly can. And if you're feeling extra generous, head to Apple Podcasts and Spotify and leave us a review.